Gonna wait to see if it's running. Yeah, so today my plan is to run my own node on Ethereum. And I might do these EVM puzzles here, which I forgot. I don't remember where I found them, but I think there are some puzzles to learn more about how the EVM works. So I think it might be interesting to do that as well. I have no idea how to do this. I remember searching this up a while ago, but Ethereum was still proof of work. So probably everything changed since the merge. And I also researched a lot and studied, read a lot of things, but the practical stuff, I don't know how to do it. I'm gonna use this extension here to read stuff. I'm also a little bit sick, so I might not speak a lot, so.
Run a node. What does it mean to run a node? Run software. Known as a client. Known as a client, this software downloads a copy of the Ethereum blockchain and verifies the validity of every block, then keeps it up to date with new blocks and transactions, and helps others download and update their own copies. With hardware. Ethereum is designed to run a node on average consumer-grade computers. You can use any personal computer, but most users opt to run their node on dedicated hardware to eliminate the performance impact on their machine and minimize node downtime. While online, running an Ethereum node may sound complicated at first, but it's merely the act of continuously running client software on a computer while connected to the internet. While offline, your node will simply be inactive until it gets back online and catches up with the latest changes. Who should run a node? Everyone. Nodes are not just for proof-of-stake validators. Anyone can run a node. You don't even need ETH. You don't need to stake ETH to run a node. In fact, it's every other node on Ethereum that holds validators accountable. You may not get the financial rewards that validators earn, but there are many other benefits of running a node for any Ethereum user to consider, including privacy, security, reduced reliance on third-party servers, censorship resistance, and improved health and decentralization of the network. Having your own node means you don't need to trust information about the state of the network provided by a third party. Don't trust.
Yeah, the hard part about this is that I don't think it's gonna be running the node. It's gonna be understanding how to interact with my own node. And hopefully I can get to the point where I don't have to use RPC providers anymore. That's the goal. I want to be able to communicate directly with the Ethereum virtual machine and also be able to get any data that I want from the EVM without having to pass through a relayer. And the reason why is because, as far as I understand, the relayer is the bridge between you and the Ethereum virtual machine, so they have the power to select different miners to send your transaction, which means that, and that's the reason why Flashbots exists, is a private relayer where they have a selected group of miners that have the privilege of making business with them, and then it's a win-win situation because in the public RPC providers, you can get front run or sandwiched attacked, which means that people see your transactions and then they exploit the transactions by placing other transactions around your transactions so that they make money off you. And this doesn't happen, or is supposed to not happen with Flashbots because they have private miners that make deals with them that they're not going to front run the users. And in exchange for that, they are allowed to work with Flashbots. But that's a problem because it becomes centralized, and then there's nothing to say that the Flashbots is not gonna start censoring people or front running them. And there's also stuff that I'm gonna study about this today, I think, which is the MEV boost. Since Ethereum went through proof of stake, I remember reading that Flashbots was going to change the way that they work, and their goal is also to become more and more decentralized because their mission seems to be also to prevent censorship and decentralized combat the centralizing force of MEV. And I think that running our own node makes it so that it's a lot better because you have direct access to transactions. Obviously, I think not obviously, but I think you're still kept by the networking protocol, which I also want to understand. So maybe I'll also try to go over this Web3 curriculum here to understand how the networking works.
In the earlier days of the network, users needed to have the ability to interface with the command line in order to operate an Ethereum node. If this is your preference, and you've got the skills, feel free to check out our technical docs. Spin up an Ethereum node. Now we have dApp Node, which is free and open source software that gives users spin up an Ethereum node. Now we have dApp Node, which
Yeah,
is free and open source software that gives users an app-like experience while managing their node.
obviously I'm gonna go for this one. I don't wanna use other software. I remember seeing there's 4 clients as well, 4 different clients, and then I think that is a given, but I'm not really sure. But I think at least from the logic or from my intuition, not even intuition, just understanding the basics of market dynamics, it seems that the client is gonna fluctuate, is gonna tend to a Pareto distribution where one of the clients has 80% of the user base. And I think that's pretty much what's happening there. And I don't remember which client it is, but yeah. Maybe I'll try to choose a different one, but I'm not sure. Because the problem with these things is that if you use the one that has the biggest user base, it becomes a self-fulfilling prophecy, just in the same way that the market dynamics work, where the person that has more money creates a symmetry of information and then they gain more and more power. And it scales exponentially because of the nature of gravity. And I think it's the same here, where if you choose, there's trade-offs obviously, but if you choose the node that or the client that few people use, you're gonna have a lot of more challenges, and it might be one of those things where it becomes problematic because then you lose your competitive advantage. So I have to think about that. And I know that they are in 4 different languages as well. I'm thinking that I'll probably select the Rust one because I really wanna learn Rust more, become better at Rust. I'm also thinking about doing lead code challenges in Rust as well at some point to become better with tree graphs and trees, whatever the structure, the name of the data structure for the Merkle tree or tree. I don't know how to say if it's tree or try or whatever. But those 3 data structures, I want to understand more how they work. There's also the other thing that now that it's proof of stake, the hardware necessary is a lot less than it was before, but I still think that the hardware necessary to run a full archive node is the same because I don't see. Yeah, I have to study more about the data availability sampling and how it works to understand because my main goal is obviously to get all the data that I possibly can to make decisions on base of on top of that. So you might have the option of running a node without using a lot of hardware, and then that would mean that it's unnecessary to do the stuff that I did, which is buy more hardware. But I think that if you want all the information or yeah, all the information from the blockchain, then you probably need the hardware anyways. So yeah, that's what they recommend actually, 2 terabytes. I thought it was gonna be less, but yeah. And the thing is, I couldn't find any SSD. I guess I could, but it's just exponentially more expensive. And my computer doesn't have slots for. That's the other thing that I'm thinking about is how are they gonna scale once it goes beyond what a hardware or SSD is capable of holding? Like how do you split the node into multiple different partitions in multiple different hardwares? And something to think about as well. I think this is the same as this one. Yeah.
In just a few taps, you can have your node up and running. DApp node makes
And close this. The poker thing that I was doing, I had a problem
spin up
with
your own
the
Ethereum node.
lifetimes. I'm gonna have to think about that a lot because the initialization of the player becomes out of scope. The values become out of scope, so I might have to redo everything.
Running your own node provides you various benefits, opens new possibilities, and helps to support the ecosystem. This page will guide you through spinning up your own node and taking part in validating Ethereum transactions. Note that after the merge, two clients are required to run an Ethereum node, an execution layer, L, client and a consensus layer, CL, client. This page will show how to install, configure, and connect these two clients to run an Ethereum node. Prerequisites. You should understand what an Ethereum node is and why you might want to run a client. This is covered in nodes and clients. If you are new to the topic of running a node, or looking for a less technical path, we recommend first checking out our user-friendly introduction on running an Ethereum node. Choosing an approach. The first step in spinning up your node is choosing your approach. Based on requirements and various possibilities, you must select the client implementation of both execution and consensus clients, the environment, hardware, system, and the parameters for client settings. This page will guide you through these decisions and help you find the most suitable way to run your Ethereum instance. To choose from client implementations, see all the available mainnet-ready execution clients, consensus clients, and learn about client diversity. Decide whether...
Yeah, here we go, opening up endless different tabs. It's always like this. Yeah, this is the same page, I think. So eventually I'm gonna get to that. Oh, it starts here actually. I think I'm gonna start from here and then close that one. And this is the same. Client diversity. So it's all the same page. And this one I read already. Okay. So there's a bunch of links, but it's all from the same page. Just different points.
Nodes and clients. Last edited at Wakaro, September 26, 2022. Ethereum is a distributed network of computers, known as nodes, running software that can verify blocks and transaction data. The software application, known as a client, must be run on your computer to turn it into an Ethereum node. Note, it is not possible to run an execution client on its own anymore. After the merge, both execution and consensus clients must be run together in order for a user to gain access to the Ethereum network. Prerequisites. You should understand the concept of a peer-to-peer network and the basics of the EVM before diving deeper and running your own instance of an Ethereum client. Take a look at our introduction to Ethereum. If you are new to the topic of nodes, we recommend first checking out our user-friendly introduction on running an Ethereum node. What are nodes and clients? A node is any instance of Ethereum client software that is connected to other computers also running Ethereum software, forming a network. A client is an implementation of Ethereum that verifies data against the protocol rules and keeps the network secure. Post-merge Ethereum consists of two parts, the execution layer and the consensus layer. Both layers are run by different client software. On this...
Now that I think about it, it might actually be a good idea to... The thing that I'm debating is because... first let me say what I was thinking about. I was gonna say that it might be a good idea to do this Web3 curriculum first, so that I work on understanding the peer-to-peer network here. That's the main one that I'm curious about. But the thing that I'm debating on whether or not which one should do first is because I remember when I was running the node for the first time before proof of stake, it was gonna take a very long time to get up to date for the current blocks and get all the information. I think it might take even months or 1 month or more to update everything. So that's the reason why I'm thinking about doing this first, because then I can run the node and start updating the information, and then as the information updates, I can go over these challenges here. But I'm not sure because it might help me, because it might depend on the way that I set up things. It might be I might set up in a way that it screws me up later, and then I have to redo everything again. So it might be beneficial to do the challenges first and then really understand how everything works, so I can set up in the best possible way before I start updating the information. But I'm not really sure.
On this page, we'll refer to them as the execution client and consensus client. The execution client, also known as the execution engine, L client, or formerly the ETH1 client, listens to new transactions broadcasted in the network, executes them in EVM, and holds the latest state and database of all current Ethereum data. The consensus client, also known as the beacon node, CL client, or formerly the ETH2 client, implements the proof-of-stake consensus algorithm, which enables the network to achieve agreement based on validated data from the execution client. Before the merge, consensus and execution layer were separate networks, with all transactions and user activity on the Ethereum happening at what is now the execution layer. One client software provided both execution environment and consensus verification of blocks produced by miners. The consensus layer, the beacon chain, has been running separately since December 2020. It introduced proof-of-stake and coordinated the network of validators based on data from the Ethereum network. With the merge, Ethereum transitions to proof-of-stake by connecting these networks. Execution and consensus clients work together to verify Ethereum's state. Modular design with various software pieces working together is called encapsulated complexity. This approach makes it easier to execute the merge seamlessly and enables the reuse of individual clients, for example, in the Layer 2 ecosystem. Simplified diagram of a coupled execution and consensus client. Client diversity. Both execution clients and consensus clients exist in a variety of programming languages developed by different teams. Multiple client implementations can make the network stronger by reducing its dependency on a single code base. The ideal goal is to achieve diversity without any client dominating the network, thereby eliminating a potential single point of failure. The variety of languages also invites a broader developer community and allows them to create integrations in their preferred language. Learn more about client diversity. What these implementations have in common is they all follow a single specification. Specifications dictate how the Ethereum network and blockchain functions. Every technical detail is defined and specifications can be found as originally, the Ethereum yellow paper. Execution specs. Consensus specs. EIPs implemented in various network upgrades. Tracking nodes in the network. Multiple trackers offer a real-time overview of nodes in the Ethereum network. Note that due to the nature of decentralized networks, these crawlers can only provide a limited view of the network and might report different results. Map of nodes by Etherscan. Ether nodes by Bitfly. Ethereum node crawler. Node watch by ChainSafe, crawling consensus nodes. Node types. If you want to run your own node, you should understand that there are different types of node that consume data differently. In fact, clients can run 3 different types of nodes: light, full, and archive. There are also options of different sync strategies which enable faster synchronization time. Synchronization refers to how quickly it can get the most up-to-date information on Ethereum's state. Full node. Stores full blockchain data, although this is periodically pruned so a full node does not store all state data back to Genesis. Participates in block validation, verifies all blocks and states. All states can be derived from a full node, although very old states are reconstructed from requests made to archive nodes. Serves the network and provides data on request. Light node. Instead of downloading every block, light nodes download block headers. These headers only contain summary information about the contents of the blocks. Any other information required by the light node gets requested from a full node. The light node can then independently verify the data they receive against the state roots in the block headers. Light nodes enable users to participate in the Ethereum network without the powerful hardware or high bandwidth required to run full nodes. Eventually, light nodes might run on mobile phones or embedded devices. The light nodes do not participate in consensus, i.e. they cannot be miners/validators, but they can access the Ethereum blockchain with the same functionality as a full node. The execution client Geth includes a light sync option. However, a light Geth node relies upon full nodes serving light node data. Few full nodes opt to serve light node data, meaning light nodes often fail to find peers. There are currently no production-ready light clients on the consensus layer, however, several are in development. There are also potential routes to providing light client data over the Gossip network. This is advantageous because the Gossip network could support a network of light nodes without requiring full nodes to serve requests. Ethereum does not support a large population of light nodes yet, but light node support is an area expected to develop rapidly in the near future. Archive node. Stores everything kept in the full node and builds an archive of historical states. It is needed if you want to query something like an account balance at block number 4 million, or simply and reliably test your own transaction set without mining them using tracing. This data represents units of terabytes, which makes archive nodes less attractive for average users but can be handy for services like block explorers, wallet vendors, and chain analytics. Syncing clients in any mode other than archive will result in pruned blockchain data. This means, there is no archive of all historical states but the full node is able to build them on demand. Why should I run an Ethereum node? Running a node allows you to directly, trustlessly, and privately.
I think I understand. So the archive stores everything, and the full node only stores the hash information that is necessary to rebuild the information. So in both of situations, I think you can get the historical data, but the archive node is the full data, and the full node is the compressed version of that, if I'm understanding this correctly.
Running a node allows you to directly, trustlessly, and privately use Ethereum while supporting the network by keeping it more robust and decentralized. Benefits to you. Running your own node enables you to use Ethereum in a private, self-sufficient, and trustless manner. You don't need to trust the network because you can verify the data yourself with your client. Don't trust, verify is a popular blockchain mantra. Your node verifies all the transactions and blocks against consensus rules by itself. This means you don't have to rely on any other nodes in the network or fully trust them. You can use an Ethereum wallet with your own node. You can use dApps more securely and privately because you won't have to leak your addresses and balances to random nodes. Everything can be checked with your own client. MetaMask, Frame, and many other wallets offer RPC importing, allowing them to use your node. You can run and self-host other services which depend on data from Ethereum. For example, this might be a beacon chain validator, software like Layer 2, infrastructure, block explorers, payment processors, etc. You can provide your own custom RPC endpoints. Publicly for the community or even privately hosted Ethereum endpoint enables people to use your node and avoid big centralized providers. You can connect to your node using inter-process communications, IPC, or rewrite the node to load your program as a plugin. This grants low latency, which helps a lot, e.g. when processing a lot of data using Web3 libraries or when you need to replace your transactions as fast as possible, i.e. front running. You can directly stake ETH to secure the network and earn rewards. See solo staking to get started. Network benefits. A diverse set of nodes is important for Ethereum.
Let me spend some time looking at this. Okay.
A diverse set of nodes is important for
This part that they talk about is the most complicated, I think, which is figuring out how to skip the other RPCs and do everything with your own stuff. Because it's gonna involve probably understanding. I think I'm gonna try to do everything with Rust, so I'm gonna have to understand how to spawn processes and manipulate the input and output from Rust while I communicate with the node.
A diverse set of nodes is important for Ethereum's health, security, and operational resiliency. Full nodes enforce the consensus rules so they can't be tricked into accepting blocks that don't follow them. This provides extra security in the network because if all the nodes were light nodes, which don't do full verification, validators could attack the network. In case of an attack which overcomes the crypto-economic defenses of proof of stake, a social recovery can be performed by full nodes choosing to follow the honest chain. More nodes in the network result in a more diverse and robust network, the ultimate goal of decentralization, which enables a censorship-resistant and reliable system. They provide access to blockchain data for lightweight clients that depend on it. In high peaks of usage, there need to be enough full nodes to help light nodes sync. Light nodes don't store the whole blockchain, instead they verify data via the state roots in block headers. They can request more information from blocks if they need it. If you run a full node, the whole Ethereum network benefits from it. Running your own node. Interested in running your own Ethereum client? For a beginner-friendly introduction, visit our Run a Node page to learn more. If you're more of a technical user, dive into more details and options on how to spin up your own node. Alternatives. Setting up your own node can cost you time and resources, but you don't always need to run your own instance. In this case, you can use a third-party API provider like Infura, Alchemy, Chainstack, or QuickNode. Alternatively, Archive Node is a community-funded archive node that hopes to bring archive data on the Ethereum blockchain to independent developers who otherwise couldn't afford it. For an overview of using these services, check out Nodes as a Service. If somebody runs an Ethereum node with a public API in your community, you can point your light wallets, like MetaMask, to a community node via custom RPC and gain more privacy than with some random trusted third party. On the other hand, if you run a client, you can share it with your friends who might need it. Execution clients, formerly ETH1 clients. The Ethereum community maintains multiple open-source execution clients, previously known as ETH1 clients, or just Ethereum clients, developed by different teams using different
Yeah, this here is very interesting. I'm definitely gonna subscribe to this because it seems better than using even though it's outside, it's still better than using Alchemy or Infura, I think.
The Ethereum community maintains multiple open-source execution clients, previously known as ETH1 clients, or just Ethereum clients, developed by different teams using different programming languages. This makes the network stronger and more diverse. The ideal goal is to achieve diversity without any client dominating to reduce any single points of failure. This table summarizes the different clients. All of them pass client tests and are actively maintained to stay updated with network upgrades. Client.
This is the execution clients. So the ones that I remember seeing was the consensus ones, which are the new ones. But for these ones, I know that Geth is the one that is used the most. But there are different opinions on that, on which one is the better one. Yeah, I think this is gonna be the one that I use. I think I'm gonna do everything on Rust. Yeah, but the problem is that's Linux. So I might have to do it with Windows. Either GIF or this one. Or it has to be GIF because I don't know C sharp. Which sucks. Or it can be this as well. What I can do is open up the virtual machine that I have, but then the problem is I have to install it in uh, the other hardware because it's currently on the main one. I have to install it on this SSD and it's installed on this one. And then I have to go over the whole stuff of setting up the virtual machine, dealing with all of the problems. Or I can use WSL, but that's the same thing because then I have to change the virtualization that I had to change before. I don't remember exactly why, but I remember I had to change at some point. I think it was when I was trying to build stuff on Solana or something like that. That I had a problem with having WSL, Windows subsystem for Linux, and the virtual machine at the same time. So I had to change some configuration on Windows. And if I wanna use the Windows subsystem for Linux, then I'm probably gonna have to disable the virtual machine. So I think between the two, I rather do it with the virtual machine. But then it becomes a problem because it's a layer of um, another layer of resistance to opening, and because then I have to open the VM and then I have to do everything on the VM. It gets more annoying. I guess I'll wait to see what consensus clients are available for Windows as well. But I'm probably gonna run the Go one then. I think Go is pretty similar to Rust, but is different. I remember doing a short course on Go. Yeah, but out of all of this, I think is either GIF or this one. I might just do it on a virtual machine as well. We'll see.
All of them pass client tests and are actively maintained. Note that Open Ethereum has been deprecated and is no longer being maintained. Use it with caution and preferably switch to another client implementation. For more on supported networks, read up on Ethereum networks. Each client has unique use cases and advantages, so you should choose one based on your own preferences. Diversity allows implementations to be focused on different features and user audiences. You may want to choose a client based on features, support, programming language, or licenses. Bisu. Hyperledger Bisu is an enterprise-grade Ethereum client for public and permissioned networks. It runs all of the Ethereum mainnet features, from tracing to GraphQL, has extensive monitoring and is supported by consensus, both in open community channels and through commercial SLAs for enterprises. It is written in Java and is Apache 2.0 licensed. Bisu's extensive documentation will guide you through all details on its features and setups. Aragon. Aragon, formerly known as TurboGeth, started as a fork of Go Ethereum oriented toward speed and disk space efficiency. Aragon is a completely re-architected implementation of Ethereum, currently written in Go but with implementations in other languages under development, e.g. Akula. Aragon's goal is to provide a faster, more modular, and more optimized implementation of Ethereum. It can perform a full archive node sync using around 2 TB of disk space in under 3 days. Go Ethereum.
Damn. So maybe this is the right way. The thing that concerns me is that it says 2 terabytes. So I wonder if I'm gonna need everything. Or it's just saying 2 terabytes should be conservative. Because this is supposed to be 2 terabytes, but then I think every time you initialize, it removes some terabytes. When it's doing the disk partition, I think. This is also supposed to be 2 terabytes. So, yeah. Hopefully this one is enough. And then the thing is, if I do it on a virtual machine, then I'm gonna have to have more space for the virtual machine as well. I think I would use the whole space, obviously, because then it would be inside of the virtual machine, but you get the point, or it's less space.
It can perform a full archive node sync using around 2 TB of disk space in under 3 days. Go. Ethereum. Go Ethereum, Geth for short, is one of the original implementations of the Ethereum protocol. Currently, it is the most widespread client with the biggest user base and variety of tooling for users and developers. It is written in Go, fully open source and licensed under the GNU LGPL v3. Learn more about Geth in its documentation. Nethermind. Nethermind is an Ethereum implementation created with the C#.NET tech stack, licensed with LGPL 3.0, running on all major
I think I'm
platforms
gonna open
including
the
ARM.
documentation
It offers great performance with
for this. Oh, there's no documentation. I guess I'll search later.
It offers great performance with an optimized virtual machine, state access, networking and rich features like Prometheus/Grafana dashboards, SEC enterprise logging support, JSON RPC tracing, and analytics plugins. Nethermind also has detailed documentation, strong dev support, an online community and 24/7 support available for premium users. Consensus clients, formerly Eth2 clients. There are multiple consensus clients, previously known as Eth2 clients, to support the consensus upgrades.
Yeah, I think so. This one I'm definitely gonna use the Rust one, but I think that the Lighthouse is the one that is being used the most, from what I remember. Yeah, but that's the one that I'm gonna use probably. So it's probably gonna be this one and Aragon that I do, since both of them allow me to do it on Windows. Three terabytes. Damn. Also under 3 days. Oh, this is Aragon's or Akula? I also don't understand if I can run either one of them or if they are linked somehow. If you run Lighthouse, you have to run a specific execution one, or I can run any of them.
Consensus upgrades. They are running the beacon chain and will provide a proof-of-stake consensus mechanism to execution clients after the merge. View consensus clients. Client. Language. Operating systems. Networks. Lighthouse. Fastest sync strategy developed by Geth. Currently its default. Nethermind only implemented the consuming part until now. They are working on enabling serving other nodes soon. Saves a lot of disk usage and network bandwidth without sacrificing security. More on Snap. Lodestar. Lodestar is a production-ready consensus client implementation written in TypeScript under the LGPL 3.0 license. It is maintained by Chain Safe Systems and is the newest of the consensus clients for solo stakers, developers, and researchers. Lodestar consists of a beacon node and validator client powered by JavaScript implementations of Ethereum protocols. Lodestar aims to improve Ethereum usability with light clients, expand accessibility to a larger group of developers and further contribute to ecosystem diversity. More information can be found on our Lodestar website. Nimbus. Nimbus is a consensus client implementation written in NIM under the Apache 2.0 license. It is a production-ready client in use by solo stakers and staking pools. Nimbus is designed for resource efficiency, making it easy to run on resource-restricted devices and enterprise infrastructure with equal ease, without compromising stability or reward performance. A lighter resource footprint means the client has a greater margin of safety when the network is under stress. Implemented by Trinity. Works like fast sync but also downloads the data needed to execute latest blocks, which allows you to query the chain within the first few minutes from starting. Syncs state first and enables you to query RPC in a few minutes. Still in development and not fully reliable, background sync is slowed down and RPC responses might fail. Learn more in Nimbus Docs. PRYSM. PRYSM is a full-featured, open-source consensus client written in Go under the GPL 3.0 license. It features an optional web app UI and prioritizes user experience, documentation, and configurability for both stake at home and institutional users. Visit PRYSM Docs to learn more. Teku. Teku is one of the original Beacon Chain Genesis clients. Alongside the usual goals, security, robustness, stability, usability, performance, Teku specifically aims to comply fully with all the various consensus client standards. Teku offers very flexible deployment options. The beacon node and validator client can be run together as a single process, which is extremely convenient for solo stakers, or nodes can be run separately for sophisticated staking operations. In addition, Teku is fully interoperable with Web3 Signer for signing key security and slashing protection. Teku is written in Java and is Apache 2.0 licensed. It is developed by the protocols team at Consensus that is also responsible for BSU and Web3 Signer. Learn more in Teku Docs. Synchronization modes. To follow and verify current data in the network, the Ethereum client needs to sync with the latest network state. This is done by downloading data from peers, cryptographically verifying their integrity, and building a local blockchain database. Synchronization modes represent different approaches to this process with various trade-offs. Clients also vary in their implementation of sync algorithms. Always refer to the official documentation of your chosen client for specifics on implementation. Execution layer sync modes. Full sync. Full sync downloads all blocks, including headers, transactions, and receipts, and generates the state of the blockchain incrementally by executing every block from Genesis. Minimizes trust and offers the highest security by verifying every transaction. With an increasing number of transactions, it can take days to weeks to process all transactions. Fast sync. Fast sync downloads all blocks, including headers, transactions, and receipts, verifies all headers, downloads the state and verifies it against the headers. Relies on the security of the consensus mechanism. Synchronization takes only a few hours. Light sync. Light client mode downloads all block headers, block data, and verifies some randomly. Only syncs tip of the chain from the trusted checkpoint. Gets only the latest state while relying on trust in developers and consensus mechanism. Client ready to use with current network state in a few minutes. More on light clients. SnapSync. SnapSync is the latest approach to syncing a client, pioneered by the Geth team. Using dynamic snapshots served by peers retrieves all the account and storage data without downloading intermediate tree nodes and then reconstructs the Merkle tree locally. Fastest sync strategy, currently default in Ethereum mainnet. Saves a lot of disk usage and network bandwidth without sacrificing security. More on SnapSync. Client. Disk size, fast sync. Disk size, full archive. Geth. 400 GB plus. 6 TB plus. Open Ethereum. 280 GB plus. 6 TB plus. Nethermind. 500 GB plus. 12 TB plus. Bisu. 750 GB plus. 5 TB plus. Aragon. N/A. 1 TB plus.
This is
Optimistic
insane.
sync. Optimistic sync is a post-merge synchronization strategy designed to be opt-in and backwards
I
compatible.
don't understand how they do it though. Because I'm pretty sure 12. And maybe I shouldn't search for this, so I don't. So it does exist, but it's super expensive. Just trying to see if I find the price. Yeah. It's almost $1,000. Yeah, but there must be a way to split between several of them.
Optimistic sync is a post-merge synchronization strategy designed to be opt-in and backwards compatible, allowing execution nodes to sync via established methods. The execution engine can optimistically import beacon blocks without fully verifying them, find the latest head, and then start syncing the chain with the above methods. Then, after the execution client has caught up, it will inform the consensus client of the validity of the transactions in the beacon chain. More on optimistic sync. Checkpoint sync. Checkpoint sync, also known as weak subjectivity sync, creates a superior user experience for syncing beacon node. It's based on assumptions of weak subjectivity, which enables syncing beacon chain from a recent weak subjectivity checkpoint instead of Genesis. Checkpoint sync makes the initial sync time significantly faster with similar trust assumptions as syncing from Genesis. In practice, this means your node connects to a remote service to download recent finalized states and continues verifying data from that point. Third party providing the data is trusted and should be picked carefully. More on checkpoint sync. Further reading. There is a lot of information about Ethereum clients on the internet. Here are a few resources that might be helpful. Ethereum 101, Part 2, Understanding Nodes. Will Barnes, February 13, 2019. Running Ethereum Full Nodes, a guide for the barely motivated. Justin LaRue, November 7, 2019. Running an Ethereum node. ETH Hub, updated often. Related topics. Blocks. Networks. Related tutorials. Running a node with Geth. How to download, run a node. Edit page. Zen mode. Ethereum 101, Part 2, Understanding Nodes. ETH101, Understanding Nodes. Quick overview. When we use the word node within this technical documentation, we're referring to an Ethereum client. An Ethereum client is a software application that implements the Ethereum specification and communicates over the peer-to-peer network with other Ethereum clients. Different Ethereum clients interoperate if they comply with the reference specification and the standardized communications protocols. While these different clients are implemented by different teams and in different programming languages, they all speak the same protocol and follow the same rules. As such, they can all be used to operate and interact with the same Ethereum network. Author, Andreas M. Antonopoulos, Mastering Ethereum, Section 03, Clients. Geth and Parity are arguably the two most common Ethereum clients. For this reason, we'll walk through how to run these clients in more detail through this documentation. Client language developers: Geth, Go, Ethereum Foundation, Parity, Rust, Ethcore, CPP, Ethereum, C++, Ethereum Foundation, Trinity, Python, Ethereum Foundation / Piper, Merriam, Ethereum, JS modules, JavaScript. Ethereum Foundation, Ethereum, J, Java, Ethereum Foundation, Harmony, Java, Ether.camp, Pantheon, Java, Peg, ACE, Ruby, Ethereum, Ruby, Jansia, Ethereum, H, Haskell, Block, Caps, Quorum, Go, a fork for Go, Ethereum, JP Morgan Chase, X, Theorem, Elixir, Jeffrey Hayes. Source has been modified from original source, *http://f-docs.org/n/latest/e3um-clients/choosing-a-client/html $-there-multiple-e3um-clients *https://github.com/consensus/e3um-developer-tools-list *e3um-clients. The client diversity we enjoy as Ethereum network participants is indicative of a healthy ecosystem. There exists a myriad of different clients, many independently developed, each with their own feature set, yet they remain interoperable with other Ethereum client implementations. Interoperability within the network is important, and it further boosts the adoption of software such as remote clients and wallets that improve the general user's experience. Running a full node / light node / test node. A few new terms here for you to digest. Let's walk through them at a high level. Full node. You're running a full implementation of the Ethereum network on your machine. This is as robust as it gets. It requires a not insignificant commitment of time and effort, as well as related hardware and bandwidth. A deep dive into the Ethereum Virtual Machine, EVM, Part 3 execution model of the EVM. This is a high-level overview of the execution model of the Ethereum Virtual Machine, EVM. It outlines the state, S, of the machine that changes between the execution steps of an executing smart contract in the EVM. This consists of the configurations that are held and rewritten before and after each execution step, which collectively could be referred to the state of the EVM. Machine state can be thought of as a snapshot of all data held in the EVM at a given moment in time. Think, state of being. This includes the aggregate data within the EVM such as account balances and smart contract instances running. The illustration below depicts the execution state as it changes after a transaction is completed. EVM execution state, overview. The execution model of the EVM includes the machine state and the network state. This overview omits the external account, wallet, and associated state as it exists.
I think I'm gonna read this stuff.
Running Ethereum full nodes, a guide for the barely motivated. Meh. Intro.
I think I'm gonna read this one first. Maybe searching is the best way. I think it's pretty clear that I'm gonna have to do the Aragons for the execution, and then the lighthouse for the validation. The only downside is that the Aragons doesn't seem to have the documentation there, so it might be harder.
Spin up your own Ethereum node. Last edit at Jamecook 1186, October 5th. Running your own node provides you various benefits, opens new possibilities, and helps to support the ecosystem. This page will guide you through spinning up your own node and taking part in validating Ethereum transactions. Note that after the merge, two clients are required to run an Ethereum node, an execution layer, L, client and a consensus layer, CL, client. This page will show how to install, configure, and connect these two clients to run an Ethereum node. Prerequisites. You should understand what an Ethereum node is and why you might want to run a client. This is covered in Nodes and Clients. If you are new to the topic of running a node, or looking for a less technical path, we recommend first checking out our user-friendly introduction on running an Ethereum node. Choosing an approach. The first step in spinning up your node is choosing your approach. Based on requirements and various possibilities, you must select the client implementation of both execution and consensus clients, the environment, hardware, system, and the parameters for client settings. This page will guide you through these decisions and help you find the most suitable way to run your Ethereum instance. To choose from client implementations, see all the available mainnet-ready execution clients, consensus clients, and learn about client diversity. Decide whether to run the software on your own hardware or in the cloud, considering clients' requirements. After preparing the environment, install the chosen clients either with beginner-friendly interface or manually using a terminal with advanced options. When the node is running and syncing, you are ready to use it, but make sure to keep an eye on its maintenance. Environment and hardware. Local or cloud. Ethereum clients are able to run on consumer-grade computers and don't require any special hardware, like mining machines for example. Therefore, you have various options for deploying the node based on your needs. To simplify, let's think about running a node on both a local physical machine and a cloud server. Providers offer high server uptime and static public IP addresses. Getting dedicated or virtual server can be more comfortable than building your own. Trade-off is trusting a third-party server provider. Because of the required storage size for full node, the price of a rented server might get high. More trustless and sovereign approach. One-time investment. An option to buy pre-configured machines. You have to physically prepare, maintain, and potentially troubleshoot the machine and networking. Both options have different advantages summed up above. If you are looking for a cloud solution, in addition to many traditional cloud computing providers, there are also services focused on deploying nodes. For example, QuickNode, Blockdaemon, Alchemy. Check out also Nodes as a service for more options on hosted nodes. Hardware. However, a censorship-resistant, decentralized network should not rely on cloud providers. Instead, running your node on your own local hardware is healthier for the ecosystem. Estimations show a large share of nodes run on the cloud, which could become a single point of failure. Ethereum clients can run on your computer, laptop, server, or even a single board computer. While running clients on your personal computer is possible, having a dedicated machine just for your node can significantly enhance its performance and security while minimizing the impact on your primary computer. Using your own hardware can be very easy. There are many simple options as well as advanced setups for more technical people. So let's look into the requirements and means for running Ethereum clients on your machine. Requirements. Hardware requirements differ by client but generally are not that high since the node just needs to stay synced. Don't confuse it with mining, which requires much more computing power. Sync time and performance do improve with more powerful hardware however. Before installing any client, please ensure your computer has enough resources to run it. You can find the minimum and recommended requirements below. The bottleneck for your hardware is mostly disk space. Syncing the Ethereum blockchain is very input/output intensive and requires a lot of space. It is best to have a solid-state drive, SSD, with hundreds of GBs of free space to spare even after the synchronization. The size of the database and speed of the initial synchronization depends on the chosen client, its configuration, and sync strategy. Also make sure your internet connection is not limited by a bandwidth cap. It's recommended to use an unmetered connection since initial sync and data broadcasted to the network could exceed your limit. Operating system #operating system. All clients support major operating systems, Linux, Mac OS, Windows. This means you can run nodes on regular desktop or server machines with the operating system, OS, that suits you the best. Make sure your OS is up to date to avoid potential issues and security vulnerabilities. Minimum requirements #minimum requirements. CPU with 2+ cores. 8 GB RAM. 700 GB free disk space. 10+ Mbit/s bandwidth. Recommended specifications #recommended hardware. Fast CPU with 4+ cores. 16 GB plus RAM. Fast SSD with 1+ TB. 25+ Mbit/s bandwidth. The sync mode and client you choose will affect space requirements, but we've estimated the disk space you'll need for each client below. Client disk size, SnapSync, disk size, full archive, Geth 500 GB plus 12 TB plus Nethermind 500 GB plus 12 TB plus Bisu 800 GB plus 12 TB plus Aragon and /A 2.5 TB plus. Note, Aragon does not offer SnapSync, but full pruning is possible, 500 GB. For consensus clients, space requirement also depends on client implementation and enabled features, e.g. validator/er, but generally count with another 200 GB needed for beacon data. With a large number of validators, the bandwidth load grows as well. You can find details on consensus client requirements in this analysis. Plug-and-play solutions. The easiest option for running a node with your own hardware is using plug-and-play boxes. Pre-configured machines from vendors offer the most straightforward experience: order, connect, run. Everything is pre-configured and runs automatically with an intuitive guide and dashboard for monitoring and controlling the software. DApp node. Avidot. Ethereum on a single board computer. An easy and cheap way of running an Ethereum node is to use a single board computer, even with an ARM architecture like the Raspberry Pi. Ethereum on ARM provides easy-to-run images of multiple execution and consensus client for Raspberry Pi and other ARM boards. Small, affordable, and efficient devices like these are ideal for running a node at home, but keep in mind their limited performance. Spinning up the node. The actual client setup can be done either with automated launchers or manually, setting up client software directly. For less advanced users, the recommended approach is to use a launcher, software that guides you through the installation and automates the client setup process. However, if you have some experience of using a terminal, the steps for manual setup should be simple to follow. Guided setup. Multiple user-friendly projects aim to improve the experience of setting up a client. These launchers provide automatic client installation and configuration, with some even offering a graphical interface for guided setup and monitoring of clients. Below are a few projects which can help you install and control clients just with a few clicks. DAppNode. DAppNode doesn't come only with a machine from a vendor. The software, the actual node launcher and control center with many features can be used on arbitrary hardware. Docker. Automatized setup using manual client setup. The other option is to download, verify, and configure the client software manually. Even if some clients offer a graphical interface, a manual setup still requires basic skills with the terminal but offers much more versatility. As explained before, setting up your own Ethereum node will require running a pair of consensus and execution clients. Some clients might include a light client of the other kind and sync without any other software needed. However, full trustless verification requires both implementations. Getting the client software. First, you need to obtain your preferred execution client and consensus client software. You can simply download an executable application or installation package that suits your operating system and architecture. Always verify the signatures and checksums of downloaded packages. Some clients also offer repositories or Docker images for easier installation and updates. All of the clients are open source, so you can also build them from source. This is a more advanced method, but in some cases, it might be required. Instructions for installing each client are provided in the documentation linked in the client lists above. Here are the release pages of clients where you can find their pre-built binaries or instructions on installation. Execution clients # execution clients. Bisu. Aragon doesn't provide a pre-built binary, has to be compiled. Geth. Nethermind. It is also worth noting that client diversity is an issue on the execution layer. It is recommended that readers consider running a minority execution client. Consensus clients # consensus clients. Lighthouse. Lodestar doesn't provide a pre-built binary, only a Docker image or to be built from source. Nimbus. PRYSM. Teku. Client diversity is critical for consensus nodes running validators. If majority of validators is running a single client implementation, network security is at risk. It is therefore recommended to consider choosing a minority client. See the latest network client usage and learn more about client diversity. Verifying the software # verifying the software. When downloading software from the internet, it's recommended to verify its integrity. This step is optional, but especially with crucial infrastructure piece like the Ethereum client, it's important to be aware of potential attack vectors and avoid them. If you downloaded a pre-built binary, you need to trust it and risk that an attacker could swap the executable for a malicious one. Developers sign released binaries with their PGP keys so you can cryptographically verify you are running exactly the software they created. You just need to obtain public keys used by developers, which can be found on client release pages or in documentation. After downloading the client release and its signature, you can use a PGP implementation, e.g. GNU-PG, to easily verify them. Check out a tutorial on verifying open source software using GPG on Linux or Windows/Mac OS. Another form of verification is to make sure that the hash, a unique cryptographic fingerprint, of the software you downloaded matches the one provided by developers. This is even easier than using PGP, and some clients offer only this option. Just run the hash function on the downloaded software and compare it to the one from the release page. For example, 1SHA-256 sum teku 22 points, client setup. After installing, downloading, or compiling the client software, you are ready to run it. This only means it has to be executed with the proper configuration. Clients offer rich configuration options, which can enable various features. Let's start with options that can significantly influence client performance and data usage. Sync modes represent different methods of downloading and validating blockchain data. Before starting the node, you should decide what network and sync mode to use. The most important things to consider are the disk space and sync time the client will need. Pay attention to the client's docs to determine which sync mode is the default. If that doesn't suit you, pick another one based on the level of security, available data, and cost. Apart from the synchronization algorithm, you can also set pruning of different kinds of old data. Pruning enables deleting outdated data, e.g. removing state tree nodes that are unreachable from recent blocks. Other basic configuration options are, e.g. choosing a network, mainnet or test nets, enabling HTTP endpoint for RPC or WebSockets, etc. You can find all features and options in the client's documentation. Various client configurations can be set by executing the client with the corresponding flags directly in the CLI or config file. Each client is a bit different. Please always refer to its official documentation or help page for details on config options. For testing purposes, you might prefer to run a client on one of the testnet networks. See overview of supported networks. Examples of running execution clients with basic configuration can be found in next section. Starting the execution client. Before starting the Ethereum client software, perform a last check that your environment is ready. For example, make sure there is enough disk space considering the chosen network and sync mode. Memory and CPU is not halted by other programs. Operating system is updated to the latest version. System has the correct time and date. Your router and firewall accept connections on listening ports. By default, Ethereum clients use a listener, TCP, port and a discovery, UDP, port, both on 30,303 by default. Run your client on a testnet first to help make sure everything is working correctly. You need to declare any client settings that aren't default at the start. You can use flags or the config file to declare your preferred configuration. Set of features and config syntax of each client differs. Check out your client's documentation for the specifics. Execution and consensus clients communicate via an authenticated endpoint specified in Engine API. In order to connect to a consensus client, the execution client must generate a JWT secret at a known path. For security and stability reasons, clients should run on the same machine, and both clients must know this path as it is used to authenticate a local RPC connection between them. The execution The execution client must also define a listening port for authenticated APIs. This token is generated automatically by the client software, but in some cases, you might need to do it yourself. You can generate it using OpenSSL. 1 OpenSLRand Hex 32 JUT Secret 2. Running an execution client. Execution and consensus clients communicate via an authenticated endpoint specified in Engine API. In order to connect to a consensus client, the execution client must generate a JUT secret at a known path. For security and stability reasons, clients should run on the same machine, and both clients must know this path as it is used to authenticate a local RPC connection between them. The execution client must also define a listening port for authenticated APIs. This token is generated automatically by the client software, but in some cases, you might need to do it yourself. You can generate it using OpenSSL. 1 OpenSLRand Hex 32 JUT Secret 2. Running an execution client. This section will guide you through starting execution clients. It only serves as an example of a basic configuration, which will start the client with these settings. You can instead choose one of testnets for preliminary testing of your setup. Make sure to substitute the path with a real one, e.g. pointing to your external drive. Including JSON RPC and Engine API for communication with consensus client. JUT secret. Make sure to substitute the example path with a real one which can be accessed by clients, e.g. /tmp/JUT secret. Please keep in mind that this is just a basic example, all other settings will be set to default. Pay attention to the documentation of each client to learn about default values, settings, and features. For more features, for example for running validators, monitoring, etc., please refer to the documentation of the specific client. Note that // in examples are only for formatting purposes, config flags can be defined in a single line. Running BSU. This example starts BSU on mainnet, stores blockchain data in default format at /data/Ethereum, enables JSON RPC and Engine RPC for connecting consensus client. Engine API is authenticated with token JUT secret and only calls from localhost are allowed. 1 BSU network equals mainnet /2 data path equals /data/Ethereum /3 RPC HTTP enabled equals true /4 Engine RPC enabled equals true /5 Engine host allow list equals * *6 Engine JWT enabled equals true /7 Engine JWT secret equals /path /to /JUT secret 8. BSU also comes with a launcher option which will ask a series of questions and generate the config file. Run the interactive launcher using 1 BSU's launcher 2. BSU's documentation contains additional options and configuration details. Running Aragon. This example starts Aragon on mainnet, stores blockchain data at /data/Ethereum, enables JSON RPC, defines which namespaces are allowed and enables authentication for connecting the consensus client which is defined by the JUT secret path. 1 Aragon chain mainnet /2 datadir /data/Ethereum /3 HTTP.
I always forget how to change the thing here. Yeah, how was it? Something like this. And it's not drives. Or disk. I think I got it. Just, the fuck? Oh, there we go. Okay.
Aragon by default performs a full sync with 8 GB HDD, which will result in more than 2 TB of archive data. Make sure datadir is pointing to disk with enough free space, or look into prune flag, which can trim different kinds of data. Check the Aragon's help to learn more. Running Geth. This example starts Geth on mainnet, stores blockchain. This example starts Geth on mainnet, stores blockchain data at /data/Ethereum, enables JSON RPC, and defines which namespaces are allowed. It also enables authentication for connecting consensus client, which requires path to JUT secret, and also option defining which connections are allowed, in our example only from localhost. 1 Geth mainnet /2 datadir /data/Ethereum /3. Check docs for all configuration options and learn more about running Geth with a consensus client. Running Nethermind. Nethermind offers various installation options. The package comes with various binaries, including a launcher with a guided setup, which will help you to create the configuration interactively. Alternatively, you find runner, which is the executable itself, and you can just run it with config flags. JSON RPC is enabled by default. 1 Nethermind.runner config mainnet /2 datadir /data/. Nethermind docs offer a complete guide on running Nethermind with consensus client. An execution client will initiate its core functions, chosen endpoints, and start looking for peers. After successfully discovering peers, the client starts synchronization. The execution client will await a connection from consensus client. Current blockchain data will be available once the client is successfully synced to the current state. Starting the consensus client. The consensus client must be started with the right port configuration to establish a local RPC connection to the execution client. The consensus clients have to be run with the exposed execution client port as configuration argument. The consensus client also needs the path to the execution client's JWT secret in order to authenticate the RPC connection between them. Similar to
So this is was one of the questions that I had in my mind right now, but this answers the question, which is which one you should run first. So you need to run the execution client first, then the execution generates the JWT secret, which is the thing that is used for authenticating. It's the same thing that you use when creating a website with Django, for example, in order to create passwords. So it's pretty much the same thing. Then you create the execution first and the consensus. So execution is kind of like the back end of a website, and the consensus is the front end. I think that's the good way to think about it.
Similar to execution examples above, each consensus client has a configuration flag which takes the JWT token file path as an argument. This must be consistent with the JWT secret path provided to the execution client. If you plan to run a validator, make sure to add a configuration flag specifying the Ethereum address of the fee recipient. This is where Ether rewards for your validator accumulate. Each consensus client has an option, e.g. suggested fee recipient equals 0 ZAP1, that takes an Ethereum address as an argument. When starting a beacon node on a testnet, you can save significant syncing time by using a public endpoint for checkpoint sync. Running a consensus client. Running Lighthouse. Before running Lighthouse, learn more on how to install and configure it in Lighthouse book. 1 Lighthouse beacon node 2 network mainnet /3 data. When a consensus client connects to the execution client to read the deposit contract and identify validators, it also connects to other beacon node peers and begins syncing consensus slots from Genesis. Once the beacon node reaches the current epoch, the beacon API becomes usable for your validators. Learn more about beacon node APIs. Adding validators. A consensus client serves as a beacon node for validators to connect. Each consensus client has its own validator software described in detail in its respective documentation. Running your own validator allows for solo staking, the most impactful and trustless method to support the Ethereum network. However, this requires a deposit of 32 ETH. To run a validator on your own node with a smaller amount, a decentralized pool with permissionless node operators, such as Rocket Pool, might interest you. The easiest way to get started with staking and validator key generation is to use the GoEarly testnet staking launchpad, which allows you to test your setup by running nodes on GoEarly. When you're ready for mainnet, you can repeat these steps using the mainnet staking launchpad. Look into staking page for an overview about staking options. Using the node. Execution clients offer RPC API endpoints that you can use to submit transactions, interact with or deploy smart contracts on the Ethereum network in various ways. Manually calling them with a suitable protocol, e.g. using curl. Attaching a provided console, e.g. getAttach. Implementing them in applications using Web3 libraries, e.g. Web3.py, ethers. Different clients have different implementations of the RPC endpoints. But there is a standard JSON RPC which you can use with every client. For an overview, read the JSON RPC docs. Applications that need information from the Ethereum network can use this RPC. For example, popular wallet MetaMask lets you connect to your own RPC endpoint which has strong privacy and security benefits. The consensus clients all expose a beacon API that can be used to check the status of the consensus client or download blocks and consensus data by sending requests using tools such as curl. More information on this can be found in the documentation for each consensus client. Reaching RPC. The default port for the execution client JSON RPC is 8545, but you can modify the ports of local endpoints in the configuration. By default, the RPC interface is only reachable on the local host of your computer. To make it remotely accessible, you might want to expose it to the public by changing the address to 0.0.0.0. This will make it reachable over local network and public IP addresses. In most cases, you'll also need to set up port forwarding on your router. Approach exposing ports to the internet with caution, as this will let anyone on the internet control your node. Malicious actors could access your node to bring down your system or steal your funds if you are using your client as a wallet. A way around this is to prevent potentially harmful RPC methods from being modifiable. For example, with geth, you can declare modifiable methods with a flag, http://API web3ft_spol. Access to the RPC interface can be extended through the development of edge layer APIs or web server applications, like Nginx, and connecting them to your client's local address and port. Leveraging a middle layer can also allow developers the ability to set up a certificate for secure HTTPS connections to the RPC interface. Setting up a web server, a proxy, or external-facing REST API is not the only way to provide access to the RPC endpoint of your node. Another privacy-preserving way to set up a publicly reachable endpoint is to host the node on your own Tor Onion service. This will let you reach the RPC outside your local network without a static public IP address or open ports. However, using this configuration may only allow the RPC endpoint to be accessible via the Tor network, which is not supported by all the applications and might result in connection issues. To do this, you have to create your own Onion service. Check out the documentation on Onion service setup to host your own. You can point it to a web server with proxy to the RPC port or just directly to the RPC. Lastly, and one of the most popular ways to provide access to internal networks is through a VPN connection. Depending on your use case and the quantity of users needing access to your node, a secure VPN connection might be an option. OpenVPN is a full-featured SSL VPN which implements OSI Layer 2 or 3 secure network extension using the industry standard SSL/TLS protocol. Supports flexible client authentication methods based on certificates, smart cards, and /or username/password credentials, and allows user or group-specific access control policies using firewall rules applied to the VPN virtual interface. Operating the node. You should regularly monitor your node to make sure it's running properly. You may need to do occasional maintenance. Keeping a node online. Your node doesn't have to be online all the time, but you should keep it online as much as possible to keep it in sync with the network. You can shut it down to restart it, but keep in mind that shutting down can take a few minutes if the recent state is still being written on disk. Forced shutdowns can damage the database, requiring you to resync the entire node. Your client will go out of sync with the network and will need to resync when you restart it. While the node can begin syncing from where it was last shut down, the process can take time depending on how long it has been offline. This doesn't apply on consensus layer validator nodes. Taking your node offline will affect all services dependent on it. If you are running a node for staking purposes, you should try to minimize downtime as much as possible. Creating client services. Consider creating a service to run your clients automatically on startup. For example, on Linux servers, good practice would be to create a service, e.g. with systemd, that executes the client with proper config, under a user with limited privileges and automatically restarts. Updating clients. You need to keep your client software up to date with the latest security patches, features, and EIPs. Especially before hard forks, make sure you are running the correct client versions. Before important network updates, F publishes a post on its blog. You can subscribe to these announcements to get a notification to your mail when your node needs an update. Updating clients is very simple. Each client has specific instructions in their documentation, but the process is generally just to download the latest version and restart the client with the new executable. The client should pick up where it left off, but with the updates applied. Each client implementation has a human-readable version string used in the peer-to-peer protocol but is also accessible from the command line. This version string lets users check they are running the correct version and allows block explorers and other analytical tools interested in quantifying the distribution of specific clients over the network. Please refer to the individual client documentation for more information about version strings. Running additional services. Running your own node lets you use services that require direct access to Ethereum client RPC. These are services built on top of Ethereum like Layer 2 solutions, backend for wallets, block explorers, developer tools, and other Ethereum infrastructure. Monitoring the node. To properly monitor your node, consider collecting metrics. Clients provide metrics endpoints so you can get comprehensive data about your node. Use tools like InfluxDB or Prometheus to create databases which you can turn into visualizations and charts in software like Grafana. There are many setups for using this software and different Grafana dashboards for you to visualize your node and the network as a whole. For example, check out tutorial on monitoring Geth. As part of your monitoring, make sure to keep an eye on your machine's performance. During your node's initial sync, the client software may be very heavy on CPU and RAM. In addition to Grafana, you can use the tools your OS offers like DOP or Uptime to do this. Further reading. Ethereum staking guides, summer ESIT, updated often. Client
I think I'm
diversity.
gonna go over this.
Client diversity.
I wanna go over this one and the other one, and then I'll search for the Aragon, and then run the Aragon first, and then the Lighthouse.
Client diversity. Last edit at Wakaro, September 26, 2022. The behavior of an Ethereum node is controlled by the client software it runs. There are several production-level Ethereum clients, each one developed and maintained in different languages by separate teams. The clients are built to a common spec that ensures the clients seamlessly communicate with each other and have the same functionality and provide an equivalent user experience. However, at the moment the distribution of clients across nodes is not equal enough to realize this network fortification to its full potential. Ideally, users divide roughly equally across the various clients to bring as much client diversity as possible to the network. Prerequisites. If you don't already understand what nodes and clients are, check out nodes and clients. Execution and consensus layers are defined in the glossary. Why are there multiple clients? Multiple, independently developed and maintained clients exist because client diversity makes the network more resilient to attacks and bugs. Multiple clients is a strength unique to Ethereum. Other blockchains rely on the infallibility of a single client. However, it is not enough simply to have multiple clients available. They have to be adopted by the community and the total active nodes distributed relatively evenly across them. Why is client diversity important? Having many independently developed and maintained clients is vital for the health of a decentralized network. Let's explore the reasons why. Bugs. A bug in an individual client is less of a risk to the network when representing a minority of Ethereum nodes. With a roughly even distribution of nodes across many clients, the likelihood of most clients suffering from a shared issue is small, and as a result, the network is more robust. Resilience to attacks. Client diversity also offers resilience to attacks. For example, an attack that tricks a particular client onto a particular branch of the chain is unlikely to be successful because other clients are unlikely to be exploitable in the same way and the canonical chain remains uncorrupted. Low client diversity increases the risk associated with a hack on the dominant client. Client diversity has already proven to be an important defense against malicious attacks on the network. For example, the Shanghai denial of service attack in 2016 was possible because attackers were able to trick the dominant client, Geth, into executing a slow disk/O operation tens of thousands of times per block. Because alternative clients were also online which did not share the vulnerability, Ethereum was able to resist the attack and continue to operate while the vulnerability in Geth was fixed. Proof of stake finality. A bug in a consensus client with over 33% of the Ethereum nodes could prevent the beacon chain from finalizing, meaning users could not trust that transactions would not be reverted or changed at some point. This would be very problematic for many of the apps built on top of Ethereum, particularly DeFi. Incorrectly split and finalize. Although these are unlikely scenarios, the Ethereum ecosystem can mitigate their risk by evening out the distribution of clients across the active nodes. Ideally, no consensus client would ever reach a 33% share of the total nodes. Shared responsibility. There is also a human cost to having majority clients. It puts excess strain and responsibility on a small development team. The lesser the client diversity, the greater the burden of responsibility for the developers maintaining the majority client. Spreading this responsibility across multiple teams is good for both the health of Ethereum's network of nodes and its network of people. Current client diversity. Diagram data from ethernodes.org and clientdiversity.org. The two pie charts above show snapshots of the current client diversity for the execution and consensus layers, at time of writing in January 2022. The execution layer is overwhelming.
So actually Lighthouse is the second one, not the most one.
The execution layer is overwhelmingly dominated by Geth, with Open Ethereum a distant second, Aragon third, and Nethermind fourth, with other clients comprising less than 1% of the network. The most commonly used client on the consensus layer, PRYSM, is not as dominant as Geth but still represents over 60% of the network. Lighthouse and Teku make up 20% and 14% respectively, and other clients are rarely used. The execution layer data were obtained from Ethernodes on 23/01/22. Data for consensus clients was obtained from Michael Sproul. Consensus client data is more difficult to obtain because the beacon chain clients do not always have unambiguous traces that can be used to identify them. The data was generated using a classification algorithm that sometimes confuses some of the minority clients. See here for more details. In the diagram above, these ambiguous classifications are treated with an either slash or label, e.g. Nimbus/Teku. Nevertheless, it is clear that the majority of the network is running PRYSM. The data is a snapshot over a fixed set of blocks, in this case beacon blocks in slots 204, 8001 to 216, 4916, and PRYSM's dominance has sometimes been higher, exceeding 68%. Despite only being snapshots, the values in the diagram provide a good general sense of the current state of client diversity. Up-to-date client diversity data for the consensus layer is now available at https://clientdiversity.org. Execution layer. Until now, the conversation around client diversity has focused mainly on the consensus layer. However, the execution client Geth currently accounts for around 85% of all nodes. This percentage is problematic for the same reasons as for consensus clients. For example, a bug in Geth affecting transaction handling or constructing execution payloads could lead to consensus clients finalizing problematic or bugged transactions. Therefore, Ethereum would be healthier with a more even distribution of execution clients, ideally with no client representing more than 33% of the network. Use a minority client. Addressing client diversity requires more than individual users to choose minority clients. It requires mining/validator pools and institutions like the major dApps and exchanges to switch clients to. However, all users can do their part in redressing the current imbalance and normalizing the use of all the available Ethereum software. After the merge, all node operators will be required to run an execution client and a consensus client. Choosing combinations of the clients suggested below will help increase client diversity. Execution clients. Bisu. Nethermind. Aragon. Akula. Go Ethereum. Consensus clients. Nimbus. Lighthouse. Teku. Lodestar, under review and audit. Technical users can help accelerate this process by writing more tutorials and documentation for minority clients and encouraging their node operating peers to migrate away from the dominant clients. Guides for switching to a minority consensus client are available on clientdiversity.org. Client diversity dashboards. Several dashboards give real-time client diversity statistics for the execution and consensus layer. Consensus layer. Rated.network. Clientdiversity.org. Pools.invest.cloud. Nodes as a service. Nodes as a service. Last edit at Wakaro, September 26, 2022. Running your own Ethereum node can be challenging, especially when getting started or while scaling fast. There are a number of services that run optimized node infrastructures for you, so you can focus on developing your application or product instead. We'll explain how node services work, the pros and cons for using them, and list providers if you are interested in getting started. Prerequisites. If you don't already have an understanding of what nodes and clients are, check out Nodes and Clients. Stakers. Solo stakers must run their own infrastructure rather than relying on third-party providers. This means running an execution client coupled with a consensus client. Before the merge, it was possible to run a consensus client only and use a centralized provider for execution data. This is no longer possible. A solo staker must run both clients. However, there are services available to ease this process. Read more on running a node. The services described on this page are for non-staking nodes. How do node services work? Node service providers run distributed node clients behind the scenes for you, so you don't have to. These services typically provide an API key that you can use to write to and read from the blockchain. They often include access to Ethereum testnets in addition to mainnet. Some services offer you your own dedicated node that they manage for you, while others use load balancers to distribute activity across nodes. Almost all node services are extremely easy to integrate with, involving one-line changes in your code to swap out your self-hosted node, or even switch between the services themselves. Oftentimes node services will run a variety of node clients and types, allowing you to access full and archive nodes in addition to client-specific methods in one API. It's important to note that node services do not and should not store your private keys or information. What are the benefits of using a node service? The main benefit for using a node service is not having to spend engineering time maintaining and managing nodes yourself. This allows you to focus on building your product rather than having to worry about infrastructure maintenance. Running your own nodes can be very expensive, from storage to bandwidth to valuable engineering time. Things like spinning up more nodes when scaling, upgrading nodes to the latest versions, and ensuring state consistency can distract from building and spending resources on your desired Web3 product. What are the cons of using a node service? By using a node service, you are centralizing the infrastructure aspect of your product. For this reason, projects that hold decentralization to the utmost importance might prefer self-hosting nodes rather than outsourcing to a third party. Read more about the benefits of running your own node. Popular node services. Here is a list of some of the most popular Ethereum node providers. Feel free to add any that are missing. Each node service offers different benefits and features in addition to free or paid tiers. You should investigate which ones best suit your needs prior to making a decision. Alchemy. Docs. Largest free tier with 300 M compute units per month, 30 M get latest block requests. Multi-chain support for Polygon, Starnet, Optimism, Arbitrum. Powering 70% of the largest Ethereum dApps and DeFi transaction volume. Real-time webhook alerts via Alchemy Notify. Best-in-class support in reliability/stability. Alchemy's NFT API. Dashboard with Request Explorer, Mempool Watcher, and Composer. Integrated testnet faucet access. Active Discord builder community with 18K users. Anchor. Docs. Anchor Protocol, open access to public RPC API endpoints for 8+ chains. Load balancing and node health monitoring for a fast and reliable gateway to the nearest available node. Premium tier enabling WSS endpoint and uncapped rate limit. One-click full node and validator node deployment for 40+ chains. Scale as you go. Analytics tools. Dashboard. RPC, HTTPS, and WSS endpoints. Direct support. Block daemon. Docs. Dashboard. Per node basis. Analytics. Chain stack. Docs. Networks.
I think I'm gonna read this one first, just so I can close this.
Running Ethereum full nodes, a guide for the barely motivated. Intro. Running an Ethereum full node might seem like a complicated endeavor, but, despite what you might have heard on Twitter, it turns out to be easy. Are you a procrastinator or slightly lazy but still want to support the Ethereum network directly? This post is for you. This article covers the experience of setting up and running a dApp node system along with alternatives for running a dedicated hardware node without expending too much time, money, and effort. Not only does the free open source software package dApp node contain everything you need to near instantly set up a computer as a dedicated server running an Ethereum full node and more. dApp node and Avido also sell pre-built systems that you can plug in and set up in an hour's time. If you know enough about Ethereum to have found this article, you're the kind of person that should be running a hardware Ethereum node at home. Pick the option that works best for you and go for it. Someone else will do it, right? The perennial question. Only a tiny fraction of the people who spend their days arguing online about cryptocurrency platforms bother contributing to the health and success of these systems. This is due to lack of direct financial incentive and the misconception that running a node is difficult and requires a high degree of expertise. Another source of friction is that most people today use laptops for their primary computer. Just about any consumer laptop sold today with sufficient SSD storage should easily run a full node, but when sleeping they get out of sync. Turn on your computer and the node starts to sync and the fans spin up, you might get an instant or two of slowdown. End result, you uninstall the node software. Desktop systems are less popular today, but if you have a recent one with an SSD you should be all set to just download the Geth client and let it run in the background without any major issues. Be sure to leave it on and adjust your system settings to prevent it from hibernating when not actively in use. However, for most enthusiasts, the answer is a dedicated system. I maintain that simple, plug it in and it works hardware is the key to creating resilient physically decentralized networks. dApp node is the best option available today to run dedicated full nodes with minimal effort and it come with added benefits. The Avido dApp node. My Avido i3, contributing to Ethereum in the laziest way possible. I had previously run full nodes on my laptops, but the minor annoyances I mentioned above led to me uninstalling them. In late 2018 I first heard about dApp node, a free open source software package that sets up a computer to run an Ethereum full node, an IPFS node, and a VPN that lets you manage it all from a simple web interface. A true lazy nerd's wonderland, you can deploy Ethereum testnet nodes, nodes for other chains, and other software packages all with a single click. To install you load up the image on a USB thumb drive and plug it into a dedicated PC. It includes the operating system and all required packages. The installer sets up the Debian.
Looks like this is not for me, so. I'm just gonna close this. And this also no. I don't think it's gonna be that hard to run. Like I said, it's harder to know the details of it. I think to run, the only thing you have to do is download the thing from GitHub, the client from the GitHub, and then use these commands here. It's probably enough. And that's gonna run, so I'm not really concerned about that because I wanna understand more
JSON RPC API.
the details around it, how the networking works, the RPC, and the specifics of the things. That's why I'm spending time reading this stuff before I install and start running.
JSON RPC API. Last edit at Jake Vernelio, September 30th, 2022. In order for a software application to interact with the Ethereum blockchain, either by reading blockchain data or sending transactions to the network, it must connect to an Ethereum node. For this purpose, every Ethereum client implements a JSON RPC specification, so there are a uniform set of methods that applications can rely on regardless of the specific node or client implementation. JSON RPC is a stateless, lightweight remote procedure call, RPC, protocol. It defines several data structures and the rules around their processing. It is transport agnostic in that the concepts can be used within the same process, over sockets, over HTTP, or in many various message passing environments. It uses JSON, RFC 4627, as data format. Client implementations. Ethereum clients each may utilize different programming languages when implementing the JSON RPC specification. See individual client documentation for further details related to specific programming languages. We recommend checking the documentation of each client for the latest API support information. Convenience libraries. While you may choose to interact directly with Ethereum clients via the JSON RPC API, there are often easier options for dApp developers. Many JavaScript and backend API libraries exist to provide wrappers on top of the JSON RPC API. With these libraries, developers can write intuitive, one-line methods in the programming language of their choice to initialize JSON RPC requests, under the hood, that interact with Ethereum. Consensus Client APIs. This page deals mainly with the JSON RPC API used by Ethereum execution clients. However, consensus clients also have an RPC API that allows users to query information about the node, request beacon blocks, beacon state, and other consensus-related information directly from a node. This API is documented on the Beacon API webpage. An internal API is also used for inter-client communication within a node, that is, it enables the consensus client and execution client to swap data. This is called the engine API, and the specs are available on GitHub. Execution client spec. Read the full JSON RPC API spec on GitHub. Conventions. Hex value encoding. Two key data types get passed over JSON, unformatted byte arrays and quantities. Both are passed with a hex encoding but with different requirements for formatting. Quantities. When encoding quantities, integers, numbers encode as hex, prefix with 0x, the most compact representation, slight exception, 0 should be represented as 0x0. Here are some examples. 0x41, 65 in decimal. 0x400, 1024 in decimal. Wrong, 0x, should always have at least one digit, 0 is 0x0. Wrong, 0x0400, no leading zeros allowed. Wrong, FF, must be prefixed 0x. Unformatted data. When encoding unformatted data, byte arrays, account addresses, hashes, bytecode arrays encode as hex, prefix with 0x, 2 hex digits per byte. Here are some examples. 0x41, size 1, A. 0x004200, size 3, \0b\0. 0x, size 0. Wrong, 0xf0f0f, must be even number of digits. Wrong, 004200, must be prefixed 0x. The default block parameter. The following methods have an extra default block parameter. ethget balance. ethget code. ethget transaction count. ethget storage at. ethcall. When requests are made that act on the state of Ethereum, the last default block parameter determines the height of the block. The following options are possible for the default block parameter. Hex string, an integer block number. String earliest for the earliest /genesis block. String latest, for the latest mined block. String pending, for the pending state /transactions. Examples. On this page we provide examples of how to use individual JSON API endpoints using the command line tool, curl. These individual endpoint examples are found below in the curl examples section. Further down the page, we also provide an end-to-end example for compiling and deploying a smart contract using a Geth node, the JSON API and curl. Curl examples. Examples of using the JSON API by making curl requests to an Ethereum node are provided below. Each example includes a description of the specific endpoint, its parameters, return type, and a worked example of how it should be used. The curl requests might return an error message relating to the content type. This is because the data option sets the content type to application/xwww form URL encoded. If your node does complain about this, manually set the header by placing h content type application/JSON at the start of the call. The examples also do not include the URL/IP and port combination, which must be the last argument given to curl, e.g. 127.0.0.1:8545. A complete curl request including these additional data takes the following form. 1 curl h content type application/JSON x post data JSON-2.0 method web3 client version params ID 67 127.0.0.1:85452. Gossip, state, history. A handful of core JSON RPC methods require data from the Ethereum network and fall neatly into 3 main categories: gossip, state, and history. Use the links in these sections to jump to each method, or use the table of contents to explore the whole list of methods. Gossip methods. These methods track the head of the chain. This is how transactions make their way around the network, find their way into blocks, and how clients find out about new blocks. Block number. Send draw transaction. State methods. Methods that report the current state of all the data stored. The state is like one big shared piece of RAM, and includes account balances, contract data, and gas estimations. ethget balance. ethget storage at. History methods. Fetches historical records of every block back to Genesis. This is like one large append-only file, and includes all block headers, block bodies, uncle blocks, and transaction receipts. ethget block transaction count by hash. JSON RPC API methods. Web3 client version. Returns the current client version. Parameters. None. Returns. String, the current client version. Example. 1//request to curl x post data, JSON erp 2.0, method web3 client version, params, ID 67, 3//result 45 ID 67, 6 JSON erp 2.0, 7 result, missed, web3 SHA-3. Returns cupcake 256, not the standardized SHA-3-256, of the given data. Parameters. Data, the SHA-3 result of the given string, net version. Returns the current network ID. Parameters. None. Returns. String, the current network ID.
I think this is a long article, so I think I'm gonna move through trying to initialize the node. Just describing the RPC methods that you can use to communicate with the node, I think. Let me see if there's anything interesting on this one first. And it doesn't look like it's a lot, so I'm gonna read this first and then I'll always try to start the Aragon client.
Networks. Last edit at Wakaro, September 26, 2022. Networks are different Ethereum environments you can access for development, testing, or production use cases. Since Ethereum is a protocol, there can be multiple independent networks that conform to the protocol without interacting with each other. Your Ethereum account will work across the different networks, but your account balance and transaction history won't carry over from the main Ethereum network. For testing purposes, it's useful to know which networks are available and how to get testnet ETH to play around with. Prerequisites. You should understand the basics of Ethereum before reading up on the different networks, as the test networks will give you a cheap, safe version of Ethereum to play around with. Public networks. Public networks are accessible to anyone in the world with an internet
This
connection.
is just talking about the networks. I thought I was gonna say something related to the nodes itself because it's right here, so I'll close this. Now I'm gonna install this stuff and start running the node. Yeah, it looks like I'm not gonna be able to do the full archive one. It's too much memory. Yeah, so the full node works fine, which is great. And then I'm still left with a lot of space to do other stuff, in case I wanna try to run Solana or Cardano as well. Damn, 5 terabytes. So all these links looks like it's just the links for the documents. I'm gonna go over everything. I think I'm gonna put some music. How the fuck did I did it? No. And there we go. Oh, there's also it's also possible to get information from Binance. I wonder if you can get to Polygon. I don't understand really well what Binance is. I think it's a sidechain from Ethereum, but I'm not really sure. Let me just check if I'm doing the incorrectly. How do I run this fucking thing? I guess I just do Aragon first. I don't think it's gonna work because I didn't install it. Didn't install it. Oh, I understand. Oh no, actually, that's not correct. It's already here, the command. Not build pin subfolder. I think I'll have Go, but maybe not. It's slightly confusing because I think what I need to do is download this stuff first and then run this thing here. But I don't know why this command comes before the explanation here. But I guess these are just sub-points explaining this one. I think I have chocolate, I don't know how to say this. But I don't have this stuff here, so I think I'm gonna install this. Uh, Everything for Windows sucks, apparently. It's always made for Linux. And it's probably because most of the servers are on Linux, but it still sucks. I might have to install the virtual machine on the new SSD and then run the stuff from the virtual machine. That's gonna be really annoying. I guess I can try to use Docker as well.
Someday, the sky is crying. Someday, I'm laughing at the moon. Someday, the sky is crying. Someday, from always being blue. Someday, the sky is crying. Someday, she says our time is due. Someday, the sky is crying. Someday, crying for the world she knew. Someday,
Love was something that she thought she could understand, but that was way before her heart was broken by a man. Oh, she's crying. Oh, I see her dying. The clouds are coming in and as she cries into a river, stars are shining bright only when you couldn't see her. Oh, she's hiding. Inside you see she's trying.
the sky is crying. I'm laughing at the moon. The sky is crying. From always being blue. The sky is crying. She says our time is due. The sky is crying. Crying for the world she knew to be loved.
Your love is like a storm. Your love that she couldn't hold on to. Yeah, your love is like a storm. Your love that she couldn't hold on to.
The sky is crying. The sky is crying. The sky is crying.
follow me to the sun, to the sea. Crystal hair in the breeze. Wanna let it fall over me. Take your hands off the wheel. Take 'em off, take 'em off. Let it go, let it breathe. Wanna take some time, come with me. I've never been one to wait. So give me your everything. 'Cause every time you look at me, I see myself in your eyes. I see myself in your eyes.
I don't think you can open Docker actually, now that I think about it.
Take a trip up the street.
Because of the virtualization configurations of my computer.
I've never been one to wait. So give me your everything. 'Cause every time you look at me, I see myself in your eyes.
It doesn't work.
I see myself in your eyes. I see myself in your eyes. I see myself in your eyes.
Ah, there we go.
I see you in everything. I see you in everything. I see myself in your eyes.
Yeah, that's what I was talking about.
In everything.
I had to disable this to run the virtual machine, I think.
I see you in everything. I see myself in your eyes. I see you in everything. I see myself in your eyes. I see you in everything. I see myself in your eyes. I see you in everything. I see myself in your eyes. I see you in everything. I see myself in your eyes. I see you in everything. I see myself in your eyes. I need someone. Should I call you up? 'Cause I need someone. Should I call you up?
do I do this? How do I run the script? As I'm just gonna search for how to run a PowerShell script. This is not building the executable, that's the problem. And now the question is, how do I open? Oh, maybe I have to reopen the whole thing. I think I'm gonna check if the path has the thing they're asking for. It has some of this path, but not specifically this one. as just program data of chocolate. But I still don't know if I need to. The other thing that I'm thinking is using Go to try to run the script, but I'm gonna search for that. Because I need to run this command here, or this file. That doesn't work. Oh, I have to see the intro variable. And I think this is Go, probably. And try to use Go to run this. Yeah, this is kind of weird.
What if one day would repeat over some years?
Let me try the easy thing first, which is just open PowerShell. It's done.
Looks like there's rain up ahead. Like there's a crack in the heavens. Feels like my day could be turning. Like I can tell that my luck's gonna change. If you could see me now, I'd probably let you down. But that's enough for me. You got me begging, baby. Looks like I'm on my knees again. Feels like the walls are closing in. Looks like I'm on my knees again. Looks like the tables have turned. Like there's a change in the weather. Feels like my time is returning. Like I'm about to get out of this cage. If you could see me now, I'd probably let you down. But that's enough for me. You got me begging, baby.
Yeah, hopefully it works. It's quite interesting to see the file, to try to understand how they wrote the code to create the stuff. I think I'm gonna practice some touch typing while this runs. Usually the installation is really annoying for this kind of stuff, so I was hoping that it would be easy, but kind of expecting to run into a bunch of different problems. It's gonna be annoying if I have to install the virtual machine though. I'm trying to avoid that as much as possible. Oh, I managed to remove the time there as well. The timer that's here. And it helps me go faster because then I don't focus on the time so much. Yeah, if this works, it shouldn't be that hard actually after that. Because then I think all I have to do is run the other command. But I think it's probably a good idea to study this as well, to understand how they built this stuff. But obviously I can't go over all of this because it would just take ages.
She said, I'm running around looking for peace of mind. So come out and change me. You were always around to make me smile.
I think it's probably more better use of my time to go through the challenges instead of studying this actually. So if everything goes well and I can run the node fast, I still have to see the lighthouse node as well, but if I can run both of them fast, I think I'm gonna start. I'm gonna do the EVM challenges that I have there, EVM puzzles, and then I'm gonna start the free code camp as well. But I think I'm gonna have to do the free code camp challenges on the virtual machine, if I remember correctly, because they talk about this, I think. Yeah, I have to use Docker. which is quite annoying. So I'm probably gonna have to use the virtual machine. But for this is not a big deal because I'm not gonna use a bunch of memory, so I already have all of the setup for the virtual machine with the one that I have right now, so nice. Let's see. So I think I have to run the executable first, and then I run this command here. I think I'm gonna close this. If I understood, this stuff that I downloaded here is something that it allows you to use the make command on Windows, but I don't think I'm gonna need it because of the chocolate stuff that I downloaded. Yeah, so this is the executable for the thing, I think. Let's just run this, see what happens.
How long have
and try to do this command here. I think something went wrong here with the size of the information being passed. Yeah, so I have to do this first. Probably because I had to allow it there. Yeah, it's still the same problem. I guess the option is to try another one. I think the problem here is that it's trying to get too much information at once. That's higher than the limit that I have for my internet. So I can't do it. So maybe the best thing to do is try to use GAF instead. Because I think I need to run this in order to download or to start Aragon, and then only after I start I can run this command here. Otherwise it doesn't know. Yeah, there are a couple of options. The problem is if the cap is on my internet, then there's nothing I can do about it. So the only option is to run another, try to run another client. and then also can try to run on Docker or on a virtual machine. But I don't think that's gonna change anything because it doesn't change the internet. So I'm thinking about trying to do GIF and stuff. The other thing I can do is go into their Discord server and ask. Someone probably has an answer to this, but I think it's probably the internet. That's the issue. And there's probably a way that I can change this somehow, because I think what's happening is that because it syncs faster, it receives more it asks more information at once, and then the other clients ask less information and then take a longer time to sync. I think that's possible as well. So there must be a way to reduce the size of this datagram here that it asks for the buffer. But then I think that's gonna be too complicated. It's probably easier to just try to use GAF instead. Because GAF, I remember actually running the node. So I know that there's a higher chance that it works. I don't know if it's gonna change so much between proof of stake and proof of work. I think I'm gonna do that actually. It's probably the easiest alternative. This is also interesting. Let me see if, okay, so it's all the same page. I think I'm gonna read all of this to understand how the protocol works. But I think before I do that, I'm gonna try to do the free code camp challenge. Close this stuff. Close this. Let me see if this works. Yeah. I guess I have to create a file. So I guess the book is the main thing. Fuck, this is gonna be a problem also. Because the default for storing the database is on the C directory. trying to understand how I can change the path for the database.
Cause when your eyes are closed, I'm dreaming wide awake. So what are we waiting for? About to lose control, about to feel the heat. Don't have to take it slow now that we're in so deep. So what are we waiting for?
Data there.
It's coming over me. We're only seeing what we wanna see. Counting seconds till we're out of reach. So far from here. Have I lost my mind? All the memories I left behind. What will they look like on the other side? So far from here. The more I want to know, the more I hesitate. Cause when your eyes are closed, I'm dreaming wide awake. So what are we waiting for? About to lose control, about to feel the heat. Don't have to take it slow now that we're in so deep. So what are we waiting?
I guess I'm gonna run this first because I think this file here is gonna install the thing, and then after that I see what's the command to start running the node, and then I pass the flag to specify the data directory, and hopefully it changes to the D disk space. Hopefully it works as also doesn't screw up because of the size of the datagram or whatever. But the thing that is concerning me is that this is saying database and then it's going through this path here. But I don't think I can use the command gaf without running the file because it's not installed yet. So I guess this is fine because it's gonna install first, and then after it installs, then I can change by passing the flags whenever I'm gonna start running the node. And then the commands are probably here and all the flags that I can pass. And the documentation. I think it's gonna work. Hopefully it's gonna work. Then after that I'm gonna read the Lighthouse book and try to run that one, and then connect the two, and then start do the AVM puzzles or the challenges from Free Code Camp. Other thing that I'm gonna do is save money to buy more RAM. I have 16 gigabytes now, but I think I'm gonna get more 16. And it's not that expensive. I don't know if I should press enter here. Or maybe it just takes a long time. Yeah, whatever, I'm gonna wait. Okay, so 2 terabytes. Yeah, I'm not gonna be able to run the archive because it looks like it's much more. Yeah, this is insane. Total storage back down to the version. 12 terabytes. Jesus. I think that, I mean, it shouldn't be impossible to solve this problem. I think that's one of the reasons why the guy that created Cardano moved away from Ethereum. There's probably another solution that is better, I think. It's one of the reasons that it makes me think that Ethereum is not going to be the main thing in the future. Because it looks like the whole move towards proof of stake is just a duct tape solution. But I could be wrong, obviously. I think it's Charles something, the name of the guy. I always forget his last name. I think I'm gonna study that as well to understand more. Because I just don't see this scaling in the very far future. Because if it's 2 terabytes, 12 terabytes now, imagine how many terabytes you're gonna need in 20 years. It's just gonna be insane amounts of data. That's the problem. And then everyone that has the full archive node has to have the whole data. Then I don't think you need the archive node to validate and run, so maybe that's... But it's still a lot of data, regardless. It's only gonna grow exponentially the more people that use it. It's not even that adopted yet, and there's all this data, so I don't see how it scales. I don't know now what's going on. I tried to press enter and didn't work. Maybe I have to wait, if who knows. Let me see something. Yeah, if I try to write, it doesn't work. I guess I just have to wait. Yeah, I think I just have to wait, and there's not much I can do. And then after the installation, then I can see the comments. What I'm gonna do is read this a little bit, and then I'm gonna start the EVM puzzle stuff while I'll wait for this. And then if it takes a lot of time, then I might just try to do the installation another way, because maybe this way isn't working. I don't know. Or I can search for videos. I think I'm gonna do that as well. Yeah, Charles Hoskinson. Hoskinson.
Charles Hoskinson.
Charles Hoskinson.
Charles Hoskinson.
I'm gonna watch these videos here as well. Might be helpful to understand. And after I watch these videos and I read a little bit of the documentation, I'm gonna do the EVM puzzles.
In this video,
I guess I'll read these later. I'm gonna watch the videos first. I'll be right back.
I will explain how to set up your own Ethereum node. Running your own node offers much more flexibility compared to node providers like Infura, and it's also a great way to understand in detail how Ethereum works. If you're new here, I'm Julian, and on Ethereum, I help Web2 developers transition into Web3. An Ethereum node is a software that runs the Ethereum network. There are many implementations of Ethereum node, and Geth written in Go is the most popular. That's the implementation we will use. You can install Geth for Windows, Linux, and macOS. You can either download an executable or use a package manager. I will show you how to do the installation on macOS with the Homebrew package manager. If you don't have Homebrew, you have to install it first. After, in your terminal, you run the following commands. After that, once Geth is installed, you will have access to the Geth executable. When you run Geth for the first time, you will need to download the data from the Ethereum blockchain. That's what we call the syncing process. Geth has 3 sync modes. The full sync mode, which will download the entire blockchain. The fast sync mode will also download the entire blockchain, but using a snapshot from another peer. And the light sync mode will start a bare minimum node with only the current state and without the historical state. The most powerful and trusted option is full sync, but it requires a lot of resources on your laptop. For the tutorial, we will keep it simple and use the light sync mode. Run this command in your terminal. It will start the node in light sync mode and connect to the Ruston testnet. You will notice the IPC endpoint should look like something like this. This is the URL of your node. You can interact with your local node using the JavaScript console or by using JSON RPC. To use the JavaScript console in a new terminal, you run this command with your IPC URL. Once the console is connected, you can run this command to see information about nodes. You can check the Web3.js documentation for a full list of commands available on the console. You can also programmatically connect to the node using Web3.js and JSON RPC. For this, when you start your node, you have to run this command. You will start a JSON RPC server at localhost 8545, which you can use as a provider in Web3.js to connect to Ethereum. So that's how you run a local Ethereum. To run on mainnet, you just have to remove the Ruston flag. It's also possible to buy a physical machine specially designed to run an Ethereum node. What do you think about running an Ethereum? Have you tried already? Let me know in the comments down below. That's it for today. See you next time.
Hey there, and welcome back to the Cyberbreeders YouTube channel. In today's video, I'm going to demonstrate how to set up an Ethereum node. Before we get into that though, here's a little background. Ethereum is a distributed, decentralized network of computers. The computers on this network are running software that can verify blocks and transaction data. In order to be considered a node on the Ethereum network, your computer needs to be running an application known as a client to communicate with the network. If you want to skip the intro and get right into the setup, I'll leave the timestamp down below in the description, but I do think the intro has some useful information. The most popular client right now is Geth, which is short for Go Ethereum, but some other popular ones are Open Ethereum and Nethermind. Depending on the client software you choose to run, you'll have a few different blockchain sync options available. In this video, I'm going to demonstrate how to set up a node in full mode. I'll mention in the video where you can change to light mode in case you don't have the hardware for a full node. Speaking of hardware, here is a screenshot from Ethereum.org of the recommended specifications. The machine I'm running this on is an Intel NUC I purchased used off eBay about a month ago. I have it on my server rack in my house in a climate-controlled area. This is just a joke. It's actually sitting on top of my washing machine, so I can connect it via Ethernet to my Comcast modem. So normally in these guide videos, I just demonstrate the process on a test virtual machine, but in this case, I'm actually going to keep this running full-time and live stream it 24/7 on YouTube. It'll have some lo-fi music in the background as well, in case you want to leave it playing throughout your day. So if you're watching this video, then that means the node is up and running, so check out the live stream on my homepage, and I will also post a link below. You might be wondering, what's the point of running an Ethereum node? Financial gain? None that I know of, but if you really believe in Ethereum and decentralized cryptocurrency, then you should consider hosting a node. Nodes hold a copy of the blockchain, they help verify each transaction, and they help keep the network secure and data accurate. Hosting a network out of your residence helps keep the network decentralized. Some people opt to host a node in the cloud, but according to ethernodes.org, 67% of the nodes are currently hosted in the cloud. If we take a look at the breakdown of the top 3, Amazon is hosting 31% of all nodes hosted in the cloud. While these are technically decentralized and run by individuals, they are run on top of large organizations who own the hardware and could change the rules at any time, which would then take out huge chunks of nodes. So now that I've finished my rant, another cool part is that you can check your wallet balance or any other details about the blockchain against your node. That means you don't need to submit your wallet address to some random third party on the internet to get details about it. Lastly, if you plan on staking Ethereum 2.0, you will need an Ethereum 1.0 node, so this video is for you. With that out of the way, let's get into it. So just for context, I'm running this on Ubuntu 20.04 LTS. LTS stands for long-term support. I'm also trying something new this week. I'm going to leave a link down below in the description that will have all the commands I'm running throughout the video. So one quick piece of advice before we begin, always double check commands that you copy and paste from random strangers on the internet. Most people are trying to do good and help you, but there are some people out there who intentionally put malicious commands in the hopes that you will copy them blindly. So the first step in this process is to install Geth. So for that, we're going to go ahead and open up terminal. So the first thing we need to do to install Geth is actually add the Ethereum software repository on our Ubuntu machine. So for that, we're going to use the following command, and this just adds the Ethereum repo to Ubuntu so that we're able to install it from apt. So type in that command, hit enter, type in your administrator password. So at this point, the Ethereum repository has been added. The next thing we need to do is apt update. So this will fetch a list of all the software available in this repository. So now that's done. I'm going to clear the terminal. So now the next step is actually install Geth. So for that, we're going to do sudo apt install Geth. And once that finishes running, you have successfully installed Geth. So next, to keep things a little bit more secure, we're actually going to create a separate user on the machine to run Geth that has little to no privileges. And this is useful in case the Geth service gets compromised. The individual who compromises the service will then not have any access to actually log into the machine. This is always an essential step no matter what service you're installing on a machine, especially if it's something that you're going to be making publicly available. So to create a new user, we're going to use the following command, sudo user add, no create home. This just means it won't create a home folder on our Ubuntu machine. And we are setting the shell to bin false. And what that does is that means this user will have no access to actually log into the machine if this user is compromised. The last parameter on this is the username you want to create. I'm calling this Metapod because Metapod is a useless Pokemon. Don't ask me why I name everything in my home after Pokemon when it comes to computers, but I do. And since this is a useless user, it's only fitting that it's a useless Pokemon. So once you get that command typed out, hit enter, and that user has now been created. If you want to confirm that user has been created, you can run the following command, cat /etc/pass wd, and then pipe grep, and then the username that you created in the above command, in my case Metapod. And here we can see the user Metapod was created, and the shell that is set on this has been false, which is exactly what we set up here. So at this point, we have Geth installed, and we have created a user that has no privileges to actually log in on this machine. So the next step in this process is actually create the directory where the chain data will actually be stored. And the server that I'm installing Geth on actually have a second internal hard drive, so that's where we're storing the data. But if you only have one hard drive, you can just store it in your home directory. So the first step for that is to verify that you're in your home directory. You can run pwd/home/sob. SOB is the username on this computer, stands for site of burritos, not the other thing that stands for. So now that we know we're in our home directory, you could run the following mkdir, which make directory -p. This just means it'll create all subfolders, not just one folder we specify. And we can create chain/data. And now what we can do is that created 2 folders, chain and data. So to confirm that, you can run cd change directory, chain, data, enter. And now if we type pwd, we can see /home sob chain data. So now the chain data will be stored in your home directory. In my case, like I said before, I'm putting this in a separate location. So I'm just gonna make that folder quick. So now we have a folder created where the chain data will be stored. We need to give our user that we created earlier permission to write data to that folder. So we're gonna clear the terminal. And for that, sudo chown, which change ownership, -R, the username that we created, Metapod or whatever you created, and then the group. So when you create a new user, the group with the same name is also created. So that's why it's Metapod, user, group, and then the path to that folder. So in your case, if you're storing in your home directory, it'd be /home/the username that you created, chain, data, enter. And now to verify that the permissions were changed correctly, you can run ls-l, home, sob, chain. And we want to see the permissions on the data folder. So don't type data here, just stop at chain, hit enter. And we can see the user and the group that own this folder, data, or metapod, which are what we changed up here. So let me just make those same changes for the folder I'm actually going to be using. So welcome to the future. If you've been watching the screen closely, you might notice it's a few hours later in the day. Had some errands to run, ran out of time filming this morning, so we are back at it. So the next step in this process is we're actually going to set up a service for Geth. And what a service is in Linux is something that actually monitors the process we're running, and if it fails or crashes, it automatically restarts it. You could run the Geth command by itself, but then if you reboot or something crashes the process, you have to manually connect in and restart it. So to configure the service, we're going to, again, type sudo. We're going to use gedit to actually edit the file. You can use vi, vim, or anything else like that if you don't have a GUI on your system. But just to make this a little bit more accessible to everyone, I'm going to use a graphical text editor. So sudo gedit, and then /etc, systemd, system, and then since we're creating a new service, the next part is what we're actually naming the service. So for this, I'm going to be calling it geth.service. Once you do that, that file will open. And for this next part, I do suggest actually copying the code from the link I have down below. You can type it out if you want, but it's quite a bit of typing. So on the link down below, you'll see a section labeled service. We're going to copy and paste that here. Should look something like this. This highlighting is kind of annoying, white on white. Anyways, let's just go through this quick and I'll explain some of the options that are available in here. So this unit section up here, we have the description. This is just the name of a description for the service. We have after and once. This just specifies when the service will start. So this is when networking has started on the machine. Down here, this is a section we need to replace. So the first is that user that we created earlier. In my case, it was Metapod. The group is also Metapod. When you create a user on Linux, it also creates a group the same name as the user by default. So whatever the username was that you created, it'll be the same group name. So next we have type simple, restart always, restart sec5. You can leave this all the default. This just means that if the service actually fails, it'll attempt to restart it every 5 seconds. And the last line that you're going to need to edit is this one that starts with exec start. So here we have the geth command, we have the --data dir. So if you remember earlier in the video, we created that chain data directory in the home directory as an example. So for you, if that were the case, it would be /home/your username /chain/data. So the next part in the command is this --, port. So by default, geth listens on port 30303, and that port is what the client listens on to communicate with other Ethereum nodes, and it also uses that to discover new Ethereum nodes. So in my case, I have a different port here, and the reason for that is that if you run geth on your system, it's going to expose your public IP address of whatever your internet service provider is if you're running this at your house. So in this case, I'm using a VPN provider. In this example, I'm using Mulvad. They do allow port forwarding, so you can use whatever VPN provider you want as long as they support port forwarding. And I'm gonna pop a quick example up on the screen of what port forwarding actually is. So by default, all ports are usually closed on your home router for security purposes. So in this case, what I'm doing is Mulvad is connecting out. I'm getting a Mulvad public IP address instead of my own IP address. And when I enable port forwarding on their service, they assign me a random port to use. So that random port that I was assigned, that's going to be using in this command because that's the port that'll be open and accessible on the internet. So if you use Mulvad, you'll go on there, configure port forwarding, and just assign whatever port they randomly assign you here. If you're running this at your home, you can just leave this as a default port and then just port forward 30303 on your router to the IP address of the server you're hosting this on. The next part is sync mode. If you remember earlier in the intro, I mentioned that you could also do light mode if you don't have the hardware to support full mode. So for that, you're just going to delete full and type light there instead. The next option is -cache, and this just specifies how much RAM you want to use in the system. If you just want to use the default, which I believe is 1024, you can just go ahead and actually delete that. You don't actually need that option. I'm using it though because the server I'm running this on has 16 gigs of RAM, so I want to use a little bit more than the default. The next option is -HTTP. This just runs the web server for Geth. This is only something used internally. This is not externally exposed. Lets you interact with Geth and collect metrics. The next one is -metrics that enables enhanced reporting for Geth. And in a future video, I'm going to explain how to set up some monitoring for Geth so you can monitor your node and see some metrics about it. The last option is max peers. They say the higher the better, but 30 is about the max you want to peer with. You can reduce this if you're seeing that you're using too much bandwidth or you have a data cap at your house. And then the last section is this install. You just ignore this. So just to quickly go over this again to make sure you have it correct. The user, this is the user you created earlier. The group is the same as the username. Data directory, this is the path to the folder that we created earlier in the example. The port, if you're using VPN, just use the port they assigned you. Sync mode, folder light, cache, adjust this to whatever amount of RAM you have on that server. Set the max peers to what you think your system can support, or just start with 30 and see how it goes. And then HTTP and metrics, those are optional, but I suggest keeping them enabled. So once you have all that done and you confirm it looks good, go ahead and click save. You can click X on this. You might get a warning like this from gedit. It's just a warning that GVF, whatever is not installed correctly. Just ignore that. So now we can verify quick that the file was created and saved correctly. So do sudo cat etc systemd system, and then geth.service. And we do see everything we configured here, everything we saved. Looks good. So the next step is to reload the service daemon so it can reread our new service. For that, we're going to run sudo systemctl daemon reload, enter. So now that has reread that directory and picked up our new service. So this one we can now start the service. So I looked into this off camera, and what happened was I actually spelled the name service wrong. So if we look, I spelled it SERIVCE, and we can see here it's looking for SERVICE. So I'll fix that quick. Basically what this is doing is we're moving the file from geth.incorrectly spelled service to geth.correctly spelled service. Clear the terminal again, and now we can try and start geth again. No errors this time. Let's check the status. Hit the up arrow on your keyboard and change start to status. And as long as you see this big green circle and active running, things are good and the service has started. Typically, if you just run a command on Linux, the output is printed to standard out, which is just the terminal screen. But in this case, we're running a service in the background. So if we want to actually see what the output is of geth, we need to run a different command. So for that, it's going to be sudo journalctl -fu geth.service. And what this does is it attaches to the geth service and prints out the data from geth. And if we look here, we can see imported new chain segment, blocks 1791, time elapsed. So we can see the age here. So this is currently processing and downloading the blocks from 6 years, 2 months, and 1 week ago. So that shows we are syncing, things are running and looking good. We can see up here, looking for peers, peer count 0, 0, block synchronization has started, found 2 peers, and we're downloading data. So now to get out of that after running that command, you can hit Control-C. That's a useful command to save in case you're trying to debug or see where your blockchain is at syncing. One other thing to note with the service that we created, so by default, it doesn't start when the computer is booted. If you do want it to start at boot, you can run sudo systemctl enable geth. And what that'll do is you'll see here, created symlink, and what that means is now it'll run at system boot. Just for the time though, I don't want this to run at boot, so I'm going to disable that. But feel free to choose whichever one you want. This is Josh from the future during editing. One other thing I forgot to mention was how to check that your geth instance is listening correctly on that external port. This will help you confirm that you have port forwarding enabled and that port is listening. So for that, we're going to open up Firefox, head on over to portchecktool.com. When you get here, it'll automatically pull in your external IP address on the host that you're on. And for the port, in my case, it is 58837. For you, though, this might be different. Remember, this is where I mentioned that random port you get from either VPN provider or whatever port you choose to forward on your firewall. So once you type that in, click check your port. And if it is successfully listening, you will see something that looks like this. Now just to test to see what it looks like if it's not listening correctly, I'm going to stop the geth service. So that has been stopped, and if we check again, we can see it's no longer listening. So once you confirm it's green and listening, you're good to go. So now we have everything set up. The last step in the process that I want to show you is actually how to connect to the geth service and how to interact with the blockchain and see what the current status is. So to do that, we're going to run sudo geth attach --data dir, and after this, you're going to put the path to where your blockchain data is being stored. In my case, media. And once you have that, go ahead and hit enter. You're going to see this. Welcome to Geth JavaScript console. And this is where we can interact with the blockchain. The first command I want to demonstrate is f.syncing. And what this shows you is the current block, the highest block that's currently syncing. If this says false, that means that your client is fully synced with the blockchain. You see this data, that means it is syncing. That's pretty much the only command I actually use at this time. There's a bunch of other commands you can look up, but at this time, this is really the one I've used or had time to research. The other cool one I did find is actually a script you can paste in this window. It'll kind of show you your current syncing status and an estimation of how much longer you have to sync. So again, I'll link that down below in the description. So once you copy and paste that, you can right click, paste, enter. Give that a couple seconds, kind of doing some math in the background, and it spits out the output, I think every 10 seconds. So here we can see 5%. Actually, no, ignore this first one because the math it's using is using an incorrect value on the first calculation, so this is not right. So we can see here we are currently 5% synced with an estimation of 565 minutes left at 387 blocks per second. It's important to note you will see this number decrease probably down to 10 or 11 per second. Once it gets further along in the blockchain, I think like maybe 3 or 4 years ago. Remember the count we saw earlier, we're at 6 years. So around 3, 4, and 5 years, a lot more transactions were happening. Therefore, it takes a lot more time for Geth to process, download, and record each of those transactions. So at this point, you are currently running Geth on your Ubuntu machine or any Linux distro you chose. One other thing I forgot to mention, if you want to stop this script, just hit Control-C, and then to exit the Geth shell that you attach to, just hit Control-D. And now you're taking out of that shell. So as I mentioned in the intro, I'm going to actually be live streaming this 24/7. So if you're watching this video, that means the live stream should be up. If you could go over there, check it out, let me know what you think. If you have any questions or comments about it, feel free to post those. I'm going to be doing some future videos with some other commands and some other things I've learned about Geth and how to actually monitor it. So that'll be coming out as well. And as always, questions or comments, feel free to leave those down below, and I'll
In previous lectures, we installed Truffle and Ganache that can easily emulate an Ethereum.
I'm not sure what's going on there.
Ethereum node for development purposes. While these fake Ethereum nodes are an easy way to test your application, you have to keep in mind that they're just emulators. They provide the same interface as an Ethereum node deployed in the public Ethereum network, but internally they work completely differently. If you want to ensure that your contract will run properly on the main network, it is highly recommended to test it with a full Ethereum node. In this lecture, we'll install a private Ethereum instance with Geth on Linux. If you are on macOS or Windows, please use one of the other dedicated lectures for those systems. Now let's start by creating the folder that will host the database and the accounts for our private node. To do that, let's open a new terminal and run mkdir -p chainskills/private. So we're doing this from our user home directory in order to create our private data directory inside the chainskills directory inside our user home directory. And then we can go to chainskills/private. Now, before creating our private instance, we have to define the Genesis block that is the block that will define the initial behavior of our blockchain instance. Creating a Genesis block file from scratch can be painful, and reusing an existing one can be a problem if its version is older than your current installation of Geth. To ensure that your Genesis block file is compliant with your version of Geth, we'll create it using a tool called Puppet. Puppet is a command line tool installed in parallel with Geth and provides features to create and monitor your own Ethereum network. Here, we'll use Puppet to create the Genesis block file. So first, make sure that you are within the private directory, that the current directory is a private one, and then you can start the Puppet command. The first thing we are asked is the name for our network that we want to administer, and we'll call it chainskills. Then we have a menu with a series of commands, and we'll choose the second one to configure a new Genesis. Then it asks for the consensus engine that we want to use. We have a choice between fhash and click, click being a proof of authority consensus algorithm, and we want to use one that's closest to the mainnet, so we're using fhash. Number 1. Which accounts should be pre-funded? None, so we can just type enter here. And then we have to specify the network identifier. For this network identifier, we must choose something different from those that are used and reserved for public networks. Number 1 is for the mainnet. Number 2 is for the modern testnet. That's now obsolete. Number 3 is for the Robston testnet. That uses a proof of work consensus algorithm, so it's also a test network. Number 4 is for the Rinkaby test network, and this one uses a proof of authority consensus algorithm. And number 42 is reserved for the parity public test network. So in our course, we'll use the network ID 4224. So you can type 4224. Anything fun to embed into the Genesis block, you can ignore that and just type enter. So now we created our Genesis, but it's still in memory, and we need to export it into a file. And to do that, we choose the second command, manage existing Genesis. The second command again to export the Genesis configuration. Then we ask for the file name, and by default it will be chainskills.json, so we keep the default, we just type enter, and we can see that here to limit the processing requirements of each.
Hello everyone, welcome to Tutorials Diary. In this video, we'll show you how to install Git on Windows system. Before we jump to installation, let's try to understand that what Git means. So you might be aware about the blockchain concept, or you have heard about the Ethereum blockchain. If you're not aware, I would recommend you to go through our old videos where we have discussed about that one. So now the challenge comes how you can interact or communicate with different kind of blockchain. That can be your Ethereum mainnet blockchain, it can be your testnet blockchain, or it can be your own blockchain which you have set up. So there are different kind of clients available in the market to interact with the Ethereum blockchain, which are ETH, which is written in C++ language, then is Git, which is written in the Go language, and then third is written in the Python language. So this video is specific to Git, so we'll talk about that only. So if you have gone through our last videos where we have shown how you can set up the Ethereum development environment before you jump to the development part, we have shown how to install Node.js, then how to install Git, Visual Studio Code, Python, and Ganesha blockchain. So in that videos, we have shown two options to install on Windows, first through Chocolate and second through direct Windows installer, and we have recommended to go for Chocolate option. So here for Git, we do have two options. We do have Chocolate option and other is Windows installer, but Chocolate option does not work as of now, which I have tried. So we show you the second option, which is direct Windows installation. So here, you can go to this link, which is on GitHub, which talk about why this is not working on Chocolate through Chocolate on Windows. So they have again recommended to go over the official download page link for Git. So this is here, you can go and download the files. So this is the file for Windows. So once you click on this one, it will start downloading for you. So this is around 40 MB file size, which will start downloading for you, and then you can install for this one. So once this will get downloaded, we'll show you how you can install that one. So this will get installed to your C folder. So maybe, I'm not sure, Chocolate, as of now, I haven't got any command which is currently working as of now. So maybe it will work in future. So once it will start working, I will share the details also in the same video description down below. So this is a link you can remember, or I will share in the video description below down. So you can just take this link and start using that one. So once it's done downloaded, you can just open that installer which you have. Just wait for it. So say yes here. So then it will start installation for you. I agree. I will install this before as very quick. Let's close this one. So now this is Git is installed in the system. Now how you can check whether it's installed successfully or not. For that one, you can open the command prompt in admin mode and just run the Git command. So let's do that one. I will just run this Git command and click enter. So this will start the network for me, and this is how it should look like. So this is how you can install Git on your Windows system, and this is how you can simply go to this URL and start downloading that Git on your systems. I'm hopeful that this video is helpful for you to install Git on the Windows system. Thanks for watching.
Hey guys, Remy here. Now in today's video, I want to show you how to set up and run your own node on Ethereum. It is very simple, virtually anyone can do it. Now let's talk for a little bit about why you want to run your own node. If you're already familiar with all this, feel free to skip ahead down to the business where I actually show you how to do it. Timestamp in the description. Now to understand this better, let's first ask ourselves, what is Ethereum? Now imagine the Google Cloud Server or the Amazon Cloud Server or any cloud server. So what are they? It's basically a virtual machine running like an operating system, running on a server that is located somewhere in the server farm in the Google headquarters or the Amazon headquarters or the Microsoft headquarters. You get the idea. So that's basically a cloud server. It's a computer that is running in the headquarters of these companies, and it allows you to connect to it from anywhere in the world, and you can run your own code on their computers. So that's all it is. So Ethereum is very similar to that, except for instead of having that virtual machine run inside the headquarters of Google or Amazon, it is running on your computer, on my computer, and on the computers of any other people who are running the Ethereum nodes. So if I'm running a node, or if you're running a node, then you're actually running this virtual machine, and anyone else who's running a node is also running it. So collectively speaking, all that computer power congregates together to create the Ethereum virtual machine, which is basically like a cloud server, but decentralized, running on multiple people's computers. And when you try to connect to it, you're connecting to other people's computers, peer-to-peer, instead of, say, the Google headquarters, which is what you do if you were to connect to the Google Cloud. So on these Ethereum virtual machines, or the machine in general, which are running on the nodes on many people's computers, we have an entire ecosystem of things that can live on it. Because well, you have the Ether cryptocurrency, which is well, fascinating in itself. It is nowhere near as complicated or interesting as the other thing that can live on the Ethereum ecosystem, which is the smart contracts, and that is the real gem of the Ethereum network. So the way that works is basically you're running some code on your Ethereum virtual machine on the nodes that I'm going to show you how to run on your own, and I'm running one as well. So you're running code on these nodes, and what's happening is that this code is basically stored on the blockchain, so on many computers at the same time, which means that this code is not the program that you're running, it cannot be censored, and it cannot be manipulated without the consent of all other people, which means that basically it's censorship resistant and it's manipulation resistant. So if you want to launch a decentralized application or a website even on the Ethereum network, on your EVM, which is going to be run by all of the people who are running nodes at the same time, nobody can censor that, because to censor this would mean to turn off all of the other nodes running Ethereum. And like I said, it's decentralized, it's not in any one place, it's all over the place, all over the world, on the computers of people like you and I. Alright, so the reason you want to run a node, besides actually supporting the Ethereum ecosystem, since the obvious benefits are if you're running the node, then you're one more person in the entire chain of nodes, making the Ethereum network ever stronger. So if you have a decentralized application, then running a node will mean that you can run your DApp or DApp on your own node, on your own local computer, and that'll be much more private, and you don't have to trust any other nodes in order to cooperate with them. You just run it on your own node and the rest of the Ethereum blockchain. Now, the other benefit will be that if you want to verify some data like a transaction, like an Ethereum transaction, all you have to do is verify it using your own local client, your own local Ethereum virtual machine. You don't actually have to trust any other nodes. So the idea here is privacy and trust. You don't have to trust anyone to use it because you can just verify it on the blockchain via your own client, and privately because you're running it on your own local machine. So without further ado, let's get straight into it, and I'll show you how to set up your own node on Ethereum. Alright, so actually installing the Ethereum node and running it on your computer is simple and simple. The first thing you want to do is to go to find the Go Ethereum repository on GitHub. So here's the URL. You can just Google Go Ethereum and it's going to be the first thing that pops up. Alternatively, type it in as you see it here, or the link is down in the description. Once you're here, all you need to do now is clone this repository into our own computer. So to clone it, we'll copy this URL right here, and let's go into the terminal. Let's make a folder called, let's call it Ethereum, and let's cd into that folder. And once you're in here, let us go ahead and clone this repository. Okay, so while we're cloning it and while it's downloading, the reason I'm using the Go Ethereum protocol is just because I like this one a lot. It's very simple and this is the one I use. But there are many other languages that also run the Ethereum protocol, and you can literally make your own if you like. You can run the Ethereum protocol in any language you like. It's not language specific, but I do like this one. Again, for no particular reason other than I find it very simple to use, and this is the one I use. You might like another one. If you want to learn more, feel free to check them out. Anyway, so now that it's done downloading, I can stop rambling about it and we can get on with it. All right, so now we have the Go Ethereum folder inside of our folder. Let's cd into it like this. And you can see we have all of the files that we just copied, cloned inside this folder. Now, in order to compile them all, just scroll down here, and you can see that it actually has instructions on how to do it. They're very detailed. So all we need to do to compile the Go program is say make, and then compile it all. So we'll go compile all of it like this. It shouldn't take too long, maybe a minute. Okay, now that is done. Now let us compile the get thing as well. I think it's already compiled, but I'm just gonna do it to make sure that it is. Yeah. And now to actually run the node, all you need to do is as you can see, to launch the get or Go Ethereum, all you need to do is run this in your terminal. Yeah. So dot slash build, because it's inside the build folder, slash bin slash yeah. This is the executable file. We are going to run it like this, and that is literally it. And at this moment on, all of this. I'll show you how to set up your own node on Ethereum. Alright, so actually installing the Ethereum node and running it on your computer is simple. So here's the URL. You can just Google Go Ethereum and it's going to be the first thing that pops up.
I think I'm gonna do exactly what he's doing there.
Pops up. Alternatively, type it in as you see it here, or the link is down in the description. Once you're here, all you need to do now is clone this repository into our own computer. So to clone it, we'll copy this URL right here, and let's go into the terminal. Let's make a folder called, let's call it Ethereum, and let's cd into that folder. And once you're in here, let us go ahead and clone this repository. Okay, so while we're cloning it and while it's downloading, the reason I'm using the Go Ethereum protocol is just because I like this one a lot. It's very simple and this is the one I use. But there are many other languages that also run the Ethereum protocol, and you can literally make your own if you'd like. Now that it's downloading, I can stop rambling about it and we can get on with it. All right, so now we have the Go Ethereum folder inside of our folder. Let's cd into it. like this. And you can see we have all of the files that we just copied, cloned inside this folder. Now, in order to compile them all, just scroll down here, and you can see that it actually has instructions on how to do it. They're very detailed. So all we need to do to compile a Go program is say make, and then compile it all. So we'll go compile all of it like this.
I probably don't have something that is needed.
It should take shouldn't take too long, maybe a minute. Okay, now that is done. Now let us compile the get thing as well. I think it's already compiled, but I'm just gonna do it to make sure that it is. Yeah. And now to actually run the node, all you need to do is as you can see, to launch the get or Go Ethereum, all you need to do is run this in your terminal, terminal. Yep. So dot slash build, because it's inside the build folder, slash bin slash, yeah, this is the executable file. We are going to run it like this, and that is literally it. And at this moment on, all of this means you are running your own node, your own Ethereum node on your machine. So here I am running the node, and it's just gonna see, I'm going to chain index, I'm importing some blocks, some verifying transactions, I'm running a full node on my machine. Now let me you can see that the US bypass by far the more, it says 64 is based. Throw yourself into the rabbit hole. I think it's one of those technologies that will revolutionize the world in ways that the
we are going to have a detailed walkthrough on how you can build your own private blockchain network. In this video, I have used my personal computer.
Halo semuanya, di sini saya akan menjelaskan tentang bagaimana cara menginstal Go Ethereum atau Get Ethereum.org untuk instalasi aplikasi Get Go Ethereum. Kemudian kita ya, di sini cek show detail. Tadi kita program C, kita jalankan di copy, kemudian oke. Untuk memulai membuat sebuah node atau private blockchain dan akun dan lain sebagainya, kita langsung buka terminal baru. Jadi ketika kita mau menjalankan sebuah get JavaScript, get ring dan lain-lain, file dan get untuk menjalankannya. Kita langsung aja ke open prom C. Tadi dia di C itu di C program file get get di sini. Kita jalankan di copy alamat dari foldernya. Kita masuk ke dalam direktorinya cd c get, kemudian oke, kemudian setelah oke baru kita jalankan get buka 2 cmd file get attach Ethereum dengan algoritma
I'm probably having issues because I wanna download on the other directory that is not the C one. I think that's what's happening here. But the issue is trying to figure out how to solve this. Or maybe I have the build here already. But I don't have this binary. Trying to think about what to do. Is this errors here are not really helpful? So it's kind of hard to know. Because the problem is if it is because of something in the path on the source codes, I'm gonna have to study all of those files and try to understand. I don't really understand Go that well as well. So I'm gonna have to understand all of the files and try to debug that. I don't think that's worth it. So try to think if there's other ways that are easier or other things that I can try. I do wanna see Docker, how to make it work with Docker as well. Because then I'm gonna have to change a bunch of things. And then I think last resort is gonna be to build another entire VM, set up everything, and then run inside of the virtual machine, which I also don't wanna do.
Let us see how to create a multi-node private network using Geth. So the initial step is to create Genesis block for both nodes, because if two nodes want to communicate with each other, they should have the Genesis block with the same Genesis configuration. So I already have created a Genesis block using the Puppet, using the default parameters. So let's go ahead and create the Genesis block. So open a command prompt, get -data dir node1 init genesis.json, and the same for node. We also need accounts on node1 and node2, so let's create that also. So account new the same for node 1. So if we look at our structure, you can see this is our current structure. Now, the next thing we need to do is to run the boot node, which will coordinate the communication between these nodes. So let's go ahead and do that using the command boot node -genkey boot key. So every node in the network has actually an address called node address, and boot node's address is generated based on the boot key. So let's create that. Now let's run the boot node based.
I think I know what I'm gonna try to do. I'm gonna try to download on the C and then change the data directory after the GIF is downloaded. Because the space is only needed for the data, so. I'm gonna install on the main thing, see if it works. Where's the English version?
In previous lectures, we installed Truffle and Ganache that can easily emulate an Ethereum node for development purposes. While these fake Ethereum nodes are an easy way to test your application, you have to keep in mind that they are just emulators. They provide the same interface as an Ethereum node deployed in the public Ethereum network, but internally they work completely differently. If you want to ensure that your contract will run properly on the main network, it is highly recommended to test it with a full Ethereum node. In this lecture, we will install a private Ethereum instance with Geth on Windows. If you're on macOS or Linux, please jump to one of the other lectures that describes the installation process for your operating system. Now let's start a new PowerShell window to create the folder that will host the database and all the files for our private node. Again, I should do everything in PowerShell on Windows. That will be easier. And the first thing I need to do is to create the chainscale/private directory under my user home directory. And to do that, I can just run mkdir. That's the PowerShell command to create a directory. -p to create all the parent directories on the path of the directory I want to create. And then I can specify chainscales/private since I am in my user directory already. So now if I go to the chainscales subdirectory in my user directory, I will find the private directory under there. Now before creating our private instance, we have to define the genesis block. That is the block that will define the initial behavior of our blockchain instance.
There's something about the path as well that I think mine is not updating for some reason because of the message that I'm receiving there. I'm gonna see if I have anything on the path. It looks like that I have Ethereum socket on the variables. It looks like I have GIF as well, so let me check the command again. Oh, so it's working. Nice. No, but it's same problem again. But at least here it works. Let me see if it works here. Okay, so the command works. Did it work? I think it worked. I'm gonna leave this running and then I'm gonna see if it's updating here. But I think it works. It worked. Oh, but the thing is, I'm gonna have to, even if it worked, I'm gonna have to stop at some point because I'm gonna search for which keywords to use. But it's still a very good sign. And hopefully it works so I don't have to do everything in the more complicated way, which I'm really trying to avoid to do. I'm gonna write this down as well. I'm gonna save this file. Maybe I should try to do the lighthouse. No? I kinda wanna do the AVM puzzles.
Now, this is the part that I did personally myself. You're supposed to run an E1.0 client. This is the good thing about all nodes is you don't have to launch it; they do it for you. The best way, right? The epic gold standard way is you set up this yourself, but this is actually quite expensive to run. I have a whole server node over there. So I'm gonna point in a corner. So I have a whole computer dedicated to running this. I'm not gonna show you the process, and this is not necessary. This is complete. It took like literally a week to do this. So yeah, I'm gonna skip this part. You don't need it for this. That's a great part of hosting on all nodes. They take care of it for you. Congrats. Next part. This is something cool. I want to explain this a little bit at the very least. Is that Ethereum 2.0 is not developed by just Vitalik, right? I think this is a point to point out that one thing cool about Ethereum 2.0 is that there are multiple clients, multiple groups developing software for it. And this is the coolest part about E2.0 is that it's not just made by Ethereum Core and this is the one piece of software you have. It is a protocol and people can use different clients. So they just look at the specifications, write their own protocol, and you're good to go. So you can choose between here. But yet again, with all nodes, they choose the protocol for you. You don't have to set this up. But I just found this kind of cool that with Ethereum 2.0 is a lot of decentralization, decentralized developers. That's core. So I just want to highlight this part that if you're running this personally, you can choose. All right. Next page, validators we want to set up. We want to set up one validator. All right, so 32 ETH. You can definitely set up more. It just gives you instructions here. If you're baller, if you just want to, if you're super baller, you want to set up like 99, 88, you know, Chinese obviously 888. That's possible too. I'm just going to set up one simple validator, and the cost is 32 ETH. I'm going to demonstrate this on Windows. So which operating system are you doing? You're going to generate this on Windows, and I'm just going to show you the process of setting up your key phrases. So one thing to keep in mind here is that it might look a little bit scary, right? Because you're going to use the CLI app, right? Command line interface app, and it might look a little bit scary, but just rest assured, it's pretty simple instructions, right? And this is why I did it live. Now, you're going to click it download from GitHub. So you're going to download it from straight from the developers, and you must make sure that it's github.com. Again, there's some scammers out there. Just yeah, there's so many scams here. Just make sure you're on official website, eth.org. GitHub.com, Ethereum, right? That's the correct one. Now, yet again, I'm gonna have to choose which release I want. So it just goes here. Why Pyromon run doesn't run with anything. This is the one we're gonna download. You can see a lot of files here. What you want to just choose for your operating system. So if you're Windows, choose Windows AMD64. Just download this file. And if you're just wait. Let me see. I'm gonna download this to downloads. That makes all more sense. Boom. Put it down here. All right. So I'm gonna download that. If you're on Linux, if you're on Mac, just go for Darwin. Darwin is Mac. Magic. All right. So let me make sure that everything here is good. Good. Just don't want to reveal too many things. I have a little secret here. I want to open it up too early. So I just downloaded a file here. It's the same file. Just put it goes into download, and I'm gonna extract here. Magic. It's going to generate this file called deposit, right? So that's the key here. So you can extract the zip file, it's extracted, and it's in this folder called deposit. Now, this is kind of where the magic starts. You can follow the instructions here. I've done it multiple times yesterday, and this is the key instruction you need to run on command line interface. Deposit.exe. You want to generate a new mnemonic, the new key phrase. You can set a value as one and a chain as main. So I'm just going to copy that for now. I'm going to do a little Windows trick yet again. Because it's a command line interface, if you just double click and run this, nothing's going to happen. It's going to open a window and it's going to close on itself. That's because it's a command line interface command. You need to be running in some sort of terminal. So yet again, in Windows, it's Shift. So you can press Shift on your keyboard and Shift, right click on that, and it says Open PowerShell window here. This is what you're looking for yet again. So it's a little bit involved. You're going to see the infamous blue screen, and this is how it's mostly run right now. Now, if you just directly run the instruction, yet again, I've done this multiple times, so I know I'm right-clicking now, pasting the command that I just copied over here. It's going to bring up an error, right? This is just kind of how Windows is set up right now. I'm using Windows 10, and it just says, okay, deposit.exe is found, right? But you need to enter a .hash in front. So I'm going to just do that /, and I'm going to paste the command here. It's just one extra step. So yet again, Windows kind of tells you what to do, and you just enter the command you got just now from me. All right, type enter, and we're starting to run. So choose a mnemonic language. You can choose between multiple languages. I'm just going to choose English. It makes more sense for me. All right, and then you have to type a password to secure that phrase. So yet again, typing a password in. Remember, this password is extremely important. If you do not remember this password, you are going to get wreckaged. So if you need to write on a piece of paper somewhere, do write it down on a piece of paper. Now you're taking to the next step. This is the magic. This is your mnemonic. This is the words that you must remember. This is the ones that you have to type down. And this is also the magic words that are going to allow you to unlock your Ethereum 2.0 once that transfer is enabled. So this is actually very, very key here. You want to make sure that you remember these keywords. Now, like I said before, I got a piece of paper to write them down, and I'm going to write them down twice, right? But that's for safety. You know, sometimes handwriting sucks. You can also print these out. That's viable. I've printed them out before, but you know, just make sure you keep them secret, keep them safe. Obviously, I'm gonna say here, I'm doing this on a live stream. Obviously, you guys see this key. This is definitely not the way you want to do it, right? If you definitely don't want to show anyone your key, you don't want to show that on camera, you don't want to do this. If someone sees this and someone tries to just enter that in, yes, they will be able to claim my Ethereum at the end. All right, so my 18K US dollars worth of Ethereum, the 32 ETH, that will be lost if I use this phrase. So just note that I'm doing this for demonstration, but this is not the key that I'm actually going to use. Right? That makes sense. All right, cool. You can one thing you can do if you want to print it out, you can just select this and it becomes copied onto your keyboard. It becomes copied, but I highly do recommend that you at least don't copy and paste in this step. So I'll write it down. Should I pretend to write it down or just write it down for real? It's gonna be very boring. So okay, I'm gonna write it down for real. Just do it correctly. Arc. You guys gonna see my awesome writing too in the end. So one of the reasons why we do this is because hackers cannot hack paper. I mean, obviously you gotta keep a piece of paper safe. You don't want anyone to, I think the biggest risk to paper is that if someone drops water on it, which could be possible, yeah, you're gonna get wrecked hard. Because if you don't remember these words, or you get a word wrong, or you're missing a word, you're gonna be in deep trouble. So I'm trying to talk and write at the same time. As you obviously know, my dual multitasking skills are not the strongest, but I'm trying to practice writing and also speaking at the same time. Famous, mom, film. So some people who are really good at this, it's actually a smart idea. So if you actually want to use a label, maybe it's very clear. I think it's very clear that that I've done this multiple times. Yeah. So it is a pain in the ass. I've done this yesterday. I spent like literally an hour doing this. Don't make mistakes in it. But the good thing is, if you make a mistake, at least you catch it. So I don't recommend at this page. The easiest thing to do at this stage is to copy and paste the last thing, and you'll 100% get it right because computers, right? But that's not the right thing. You want to make sure that you roll it down correctly. They can read it. That you're good at typing. Oh yeah, I got it. All right, so that's a success. Typed the words correctly, and we are good to go. So it says creating keys, verifying deposit keys, success. Very safe too. So keep this safe, keep it secret, keep it safe. All right, so pressing key, we're done here. That's finished. So this is what we wanted. We wanted at this point to generate the keywords. So get the key files ready and the validator files ready, and also get the deposit JSON ready as well. We are ready for the next step. Now this is the step where you're going to add the file over. So let me just go to waiting for wallet confirmation. This is when MetaMask pops up and it tells. All right, this is where you can always hit reject key. That's not.
I think I'm gonna try to install since I'm here, I'm gonna try to install the lighthouse stuff. And then I'll probably leave to another time to do the EVM puzzles and the free code camp. I think this one is gonna be easier because I already installed the only thing that it's probably not gonna work, the command here is make, but I think it's worth trying. And I think the only thing I need is the secret key there, and then after I install this, I can connect this one with the other one, and then is all you need to do. I'm gonna restart this one with the additional commands that I wanna pass. And spray that it works. The other thing that I have to understand and study is the relationship between them. I know that the execution client, I think the block builders use, and then the validation is done with the data availability sampling. I remember reading a lot of stuff on that, but I don't know the specifics and what goes on the actual software or code. I'm gonna have to study more about that, I think, to understand how they communicate. Not just on the node, but on the whole network. I think I'm gonna stop this one already. Oh, it was quick, so I think it was quick because it wasn't syncing. It's just I think you have to connect the other one first. I wanna wait for this one to install, then I'm gonna search the commands for this one, the flags to pass. Then once that is done, then I pass the flags and start this one, and then see how to connect both. Yeah, fuck. It is the same problem that I had with the Go client, because I'm installing on another hard drive. You know, I'm seriously considering installing the VM and doing everything on the virtual machine, because Windows is a pain in the ass for this kind of stuff. But then it just adds a bunch of complications as well, because to communicate with the node from outside of the virtual machine to inside of the virtual machine, also I'm gonna have to spend a lot of time trying to understand how that works. I think it's not that complicated, probably because you're putting the network on the local host, but it can be complicated because it might be different the way that the virtual machine connects with the main host, and the protocols to communicate between them might be very difficult. And I think the issue here is not that I don't have this installed. I think the issue is that I'm installing on the D directory, and then it looks for the path variables on the C directory, and it doesn't find it because I'm on the wrong one, I think. But I'm not really sure if that's the case. Yeah, see here the path. It's on the C directory. It's probably the issue. Well, the biggest problem with stuff like this is that then you have to look at the whole code to understand what's going on. That's the problem. Because I don't know which portion of the code to set up everything. These lines are written and then how to change them. And maybe I can open them with VS Code and then explore, but it's gonna be difficult. That's the issue. Program not found, CMake installed. I think I'm gonna try to open this on VS Code and try to debug this stuff. If it fails again. Yeah. Problem is, I don't know for sure if that's the file being run here. I think it is because probably what Chocolatey with the make thing does is allow you to run this file, because this file is for Linux, but then once you use Chocolatey or whatever, however you call that, it allows you to use this file, but I'm not sure if that's the case or not. Maybe I should just research that. What does the make command does? I think it's using these paths here to find the environment variable somewhere. Either one of these. I think it's this one because the error message that I'm getting. I have to see the path for the... First I have to find the path that they're using here, and then I have to change the path to the one that is on my path, I think, for running this CMake. Or I can try to do the same thing that I did with the Go client, which is to download on the C disk and then see if I can pass or store the data, pass some flag to store the data on the D directory or the D disk. So I guess this is the file that contains the flags, and that's how they're putting the flags. And I guess I can do the same thing that I did with the Go client using this data directory to specify the folder. So install Lighthouse on the C directory and then initialize it with the data dir. I need to find the error here that I'm getting, or I'm not sure if it's gonna be specified on the file or not. It's running cmake on this stuff here. Yeah, I need to figure out how this thing finds the cmake path. Hmm. Yeah, so I think I'm starting to understand. that this file is the one that is being used to build, and then the path is declared here. Targets. But then why it's only release? So it's probably this one that is being run. I'm gonna check to see if make C is on the path. Environment variables path. I think it fails as is writing this file here. That's what's happening. And it's because of the CMake. think I already did this. How do I do this? Oh, I think I saw this command before as well, but I think I did it for something else. But I remember writing this down as well. I think I'm gonna reinstall. Just to see if it goes into the path. Then I'm gonna check the path to see if it's on the path or not. I'm gonna write this down. If it's not on the path, I'm gonna manually put there. And the path is just typing environment variables. I just typed it like this. Edit the system environment variables. That's how the operational system finds the variables. It doesn't look like it's on the environment variables, so I think I'm gonna install. There's chocolate there, chocolate. But there isn't the specific thing. Just trying to see, because there's a lot of environment variables, so yeah, but doesn't look like it really exists. So I'm gonna add it here. Okay, I added there, let's see if it runs now. If it doesn't, then I might spend more time trying to understand how the software is invoking that thing. But I think the most likely thing that I'm gonna do is to try to install it on the C directory and then just specify the data dir flag variable, so that I install it the easy way and then redirect the data into the SSD that I have. Or cargo install path like toss. Oh yeah, I haven't seen that before. the command that it's using. Yeah, but I think I'm correct then. The make command is running that file there that I was watching, which is the make file. And then that file does everything that it needs to do to set up or to install the thing. Yeah, it looks like I'm getting the same error. So let me go back to this, and I'm gonna try to understand. Path, lighthouse.